Korea expressed its support and willingness to cooperate for the Asian outlook on the Indo-Pacific, an initiative that focuses on maritime cooperation, connectivity, sustainable development, and economic cooperation. It is indeed fitting that this theme of this year's CAPER, Igniting Asian Green Energy and Blue Economies, aligned seamlessly with these priorities. Recognize the growing importance of sustainable marine resources and energy development. NAEK and AAET have been strengthening their collaboration in climate technology for several years. Last year, we surveyed Korean and Asian experts on the demand for climate technology cooperation, and water treatment was identified as an area with immense demand. As a response, we proudly inaugurated the Asian Korea Water Treatment Working Group earlier this year, inviting 20 experts from 7 countries in a shared mission. Building on these initiatives, this forum aims to provide a platform for the exchange of insight on policies and technologies in the water treatment and energy sectors. I am confident that this forum will serve as a catalyst for technological advancement, economic growth, and sustainable development in ASEAN and Korea. Once again, I would like to extend my heartfelt thanks to all of you for joining this forum. I hope you all enjoy a great time of networking and collaboration. Thank you.
Thank you very much for the inspiring speech, President Kim. Now it's time for the sessions here. This morning, we are going to have 2 sessions. First session will be on the more on the policy-oriented. Second session will be technology-oriented. I will chair the first session, and I turn the microphone to Dr. Lee for the technical session chair. Now it's time for the first session. We have 2 speakers this morning. Originally, Dr. Swanto is the first speaker, but we'll change the order. So we'll change the order, and speaker from the NAEK, Dr. Sang-Hyup Lee, is going to the first speaker. Dr. Lee is currently the president of National Institute of Green Technology, which is a national think tank for climate technology in Korea. He will be the speaker to talk about the boiling water, rather interesting title. Now let's welcome Dr. Lee.
Good morning. Nice to meet you. My name is Sang-Hyup Lee. I am the president of the National Institute of Green Technology. Today, I am very happy as a speaker at this place. Today, where is my presentation file? Korea? Yes, and my presentation will go beyond the practical engineering talk. So I will focus more on the big picture talk in the field of the water resources. Okay. 이거 말고. My title, the title of my title of presentation is boiling water. Yes, water is boiling now because of the end of the global warming, start of the global boiling. Yeah. UN Secretary some months ago, UN Secretary said to the stop the global warming period, and now is the global boiling period is started. Yeah. It's not my remarks. Yeah. So I guess my presentation file is in the airplane from Seoul. Oh, okay. Yes, yeah. My water is end of the boiling. What? Yes. Again, thank you. So my title of presentation is boiling versus and water, and my our institute name is the National Institute of Green Technology. So I am the president, and my name is Sang-Hyub Lee. First of all, I think I give the short introduction about our institute. The name of our institute is National Institute of Green Technology. It's shortly NIGT, but it is lots of person mistakes the night, NIGHT, but it's not night. Correct name is the NIGT, but sometimes some person said to me, it's a night, KNIGHT. He is the night. We are not night. We are NIGT. So before mentioned, UN Secretary some months ago said the end of the global warming period started the global boiling period. So NIGT was established 10 years ago. The important role is international cooperation in the climate change period. So if we have any something to cooperate with Korea, note the firstly NAEK and second NIGT. It's a night. Yeah. So yes, firstly, I talked about the condition of the Earth. Before mentioned, the global, the whole world is not hot. It's becoming boiling. The world global warming is end, and the global boiling is started. If the Earth is boiling, and if the Earth is boiling, the water on the Earth is begin to boil as well. So the title of my presentation is boiling water. So do you know the New Jeans? No? New Jeans is a famous, world famous Korean K-pop singer. Yeah, New Jeans. So search the Google, the New Jeans. It's very just like New Jeans, the Earth is boiling with the New Jeans K-pop group, and the Earth is boiling with the climate change, and the ocean are hitting record high temperature this year. Please focus on the word of the new. Like New Jeans, the Earth is come to us as a new water and a new Earth, and like New Jeans, it's same the situation. Water is a new I want to call the new Earth and the new water. And from this slide, I give the presentation some topics about the new water. Yes, I think there are truths that does not change even if new water appears. Two components of important thing is abundant quantity and the safe quality. And now is the new earth and new water is needed. So I called, I think the new one is called new abundant quality, and the new safe quality is according to the global boiling period. And I think the case, firstly, I think the case of abundant water plus boiling conditions. Then the water cycle, I think it is my personal opinion. If the global is boiling, Earth is boiling, the water cycle of the Earth system is accelerated. This is a bit on exaggeration. It's just a personal opinion. If the cycle speed now is the 80 kilometers per hour in the past and now, if the water Earth is boiling, the speed is high to 160 kilometers per hour when the Earth is boiling, and the water cycle is speed up, and various efforts should be needed to store and secure water resources. Efforts are being made to reuse used water as a method to secure water resources, except for water cycle based on the cycle. I would call this produced reused water, this water, I called this water is a re-water. And we try to keep the quantity of the water resources in the period of the global boiling. We should make the two method. We make the big bowl, and next second one is the we reuse the used water is called the re-water. And efficient water storage and management are the key technology, especially in Asia. The Asian region faces the highest water disaster risk among the all continents, particularly due to the flood, as seen in this graph. Asia is the top, especially the flood disaster is the highest in the among the 6 continents. To solve this issue, we need to increase the water storage capacity. There are 2 ways for this. One is increase the number of water bowls and enhance their individual volumes, the volume up, and increase the number of the bowls. And next, let me talk about the water quality, new safe water quality. What happened? What would happen to water quality if the Earth is boiled over? Hot temperature would affect the aquatic system. I thought, what is happening when river is hot temperature, which are the most utilized water resources? 8 years ago, I conducted research related to the green algae blooming in the water in Korea. Green algae blooming are affected by the pollution source, water temperature, and the residence time in the stream. Increasing temperature in river have raised the concern about the safety of tap water because of the green algae blooming. So to solve this problem, green algae blooming problem, advanced and the super water treatment technologies are needed. So because of the green algae blooming, it's a Korean case, it's a US case, Lake Erie. And because of the green algae blooming, the tap water, drinking water, there are some concern and worry on the drinking waters. So we need the advanced treatment and the super or hyper water treatment process. This is very famous for 100 years. Is a sand filtration process. I think the sand filtration process is the king of the drinking water treatment process. However, green algae blooming because of the earth boiling, super and hyper water treatment process and the famous advanced water treatment process is the membrane filtration. However, membrane filtration process need the high energy, and sometimes some countries use the hyper and the super advanced treatment process is called electrodialysis, electrophoresis. So these two processes need a high electricity energy. So these two advanced and hyper advanced water treatment process, high energy intensive process compared to the sand filtration. Sand filtration is very low energy consumption processes. However, according to the global Earth is boiling, these two energy intensive process needed. And I think the global boiling affect water quality more than quantity. To produce the safe water, energy intensive process are being needed. In the global boiling area, I think this is the research on the water treatment technologies that use energy efficiently is needed to ensure safe water quality. We water quality, water specialized engineers should catch the two rabbits. One rabbit is a safe water quantity, and one more rabbit is the energy efficient water treatment process we process. But it is very difficult to catch the rabbits simultaneously. But however, in other country, in the case, for example, Germany, throw the one stone, catch the two flies. So it's the same thinking. And one is the one more important thing of water. Is most important thing of water is flow well, and another important component is this is abundance and consistency and stability and non-stop. It's a Korean word. 부족함 없음, 항구성, 안정성, 비단절성. It's the same meanings. Abundance, consistency, stability, non-stop. So, according to the, however, the Earth is boiling. The most important 5 components of water: flow well, abundance, consistency, stability, non-stop. We should keep these 5 components. And energy in water treatment process, I think the energy big core in water treatment is the pumps. So the pump play an important role for achieving the most important component, flow well, without problem. However, pump consumes about 47% of the energy in water treatment process. So in order to achieve energy efficiency in the water treatment process, efficient energy use in pump should be most important thing. But how in generally, lots of water and wastewater treatment the pump use the AC nowadays. However, nowadays the increase according to the renewable energy production, lots of pump change it to AC to DC. So in water engineers consider about the DC how we use the DC pump. And this is the Nicola, the developer of the AC, and he is the Edison. He's very famous compared to the Nicola. He developed the DC. This is a Korea KEPCO. KEPCO is the Korean company to manipulate the electric grid, power grid. So in order to reduce the global warming, energy production based on the fossil fuel decreased. Various technologies of renewable energy production are being developed and used. So the DC, the usage percent increased gradually. I think that electricity energy area, we water treatment specialist, how we utilize the DC in water and wastewater treatment plant. And Seoul has 6 wastewater treatment plant and 5 water treatment plant. This plant consumes 30% of the city public sector electricity. I think the situation would be similar in ASEAN countries. I believe that wastewater treatment plant and water treatment plant need to keep pace with the period of the non-fossil based renewable energy. And this is the water treatment plant and wastewater treatment plant. Nowadays, this is a one-way energy supply system. It's a big fossil fuel-based energy production facility give the energy to the water treatment plant and wastewater treatment plant. However, owing to the renewable energy production facility increased, the wastewater treatment plant and wastewater treatment plant also receive the renewable energy. And this is energy cloud system. This is energy cloud system as a renewable energy system, and the originally fossil fuel energy water treatment energy production system. And in the future, I think the water treatment plant and wastewater treatment plant located into the energy cloud systems. So water treatment plant and wastewater treatment plant will be component of the energy cloud systems. So, however, water is very perfect analog sensitive materials. So water that produced on the energy cloud system like this is called, in my opinion, water is a digital water. And however, it is very difficult to think the water as the digital. The water is perfectly analog materials. However, we should change the thinking about the water from analog materials to digital materials. And this is the electrification and the digitizing. It's the I water. It's this I made it this word. This is AI robot. This is Korean. From now, I translate into English. It's not correct. The AI robot asks itself question while looking the analog water. This 생각 is this is the what if get wet and lost. I don't need these substances. Water itself. How can it be so versatile? It's better than me. It is a substance that can be predated by 0 and 1. It is something that I can manipulate as I will. So the AI robot is very smart. It's a self answer. Self answer is the now is my AI time. So let's challenge it to discover the way to represent that water as 0 and 1 fighting. But it seems like a very difficult task. As an alternative, consider the digital mimic method. Thank you for watching and listening.
Thank you very much, Dr. Lee. To those of you who joined us on online, I have to tell you this, we changed the schedule. Our original first speaker, Dr. Duanto, will make a presentation now, and the original second speaker, Dr. Lee, just finished his presentation. Okay, our second presenter is Dr. Harold Duanto. He is an AAET Senior Fellow, former President of Institute of Engineers, Indonesia, and Vice Chairman of Indonesian Chamber of Commerce and Industry. Actually, he was here until this morning, but he had to leave due to the unforeseen circumstances. So he's in Jakarta. He is going to present real-time online. So we have 3 modes of presentation this morning already: recorded version, here, and the online version. So Dr. Duanto, are you ready? Okay. He will give us a talk on Indonesia EMAS 2045, our aspiration to become the 5th largest economy in 2045. So when he is ready, we can listen to Dr. Duanto. Okay, now please welcome Dr. Duanto. Yes, just give us a couple of minutes to get Dr. Duanto online. He's still flying. Do you want to use a couple of minutes to talk about your? Yeah, we are trying to get Dr. Duanto. In the meantime, Dr. Lee, you can have some minutes to talk about your project.
Just I introduced my institute. So in front of you, I put the brochure of our institute. Yes, but I love the user guide, with the words of user guide, instead of the introduction or pamphlet. So, and this is the inside. So five circle, and the 5 circle are connected by the road. Yes, it's the process of our business, of our institute. First, data, and the second, data analysis, and the third is regulation, innovation, and finally, global incorporation and the global connection. And lastly, we make the big business in the counter country. Yes. So we are the agency. We are agency to connect the information, technology, and fund. So we work together with the World Bank and the ADB, Asia Development Bank, and the Korean Import and Export Bank. So we are one of the member of the Korean National Research Institute. In Korea, 55 national institute, except for our institute, 24 national institute developed the technology by himself. We don't develop the technology. So there is no laboratory and white gown. So we have policymaker and regulation developer.
Okay, thank you. Thank you. Yeah. We have to change the schedule actually. Since Dr. Duanto is not available, he may be on the flight now. So we will move his presentation to the last presentations part, which is the end of the technical session 2. So we have to move on. So I will finish up the first session, and then I will turn the microphone over to the next session moderator, Dr. Lee Yoon-fu. So Dr. Lee, microphone is yours.
Thank you very much, Professor Park. Very good morning, ladies and gentlemen. I am Dr. Lee, Executive Director of Sepakat Setia Perunding. I'm from Malaysia, and I'm also the immediate past Honorary Treasurer of IEM. Okay, today I'm also very honored to be here to be your moderator for this technical session. Okay, to start our session, today we have 4 speakers. Will present in, 3 of them will present in physical, and one of them, which is Professor Yang Hui-Ying, will present in through the virtual Zoom platform. And lastly, we will try to put in Dr. Duanto if he managed to get ready in time. Okay, without further ado, I will introduce you the first speaker, Dr. Stephen Lim. Dr. Stephen Lim is a chemical engineer. He has a bachelor degree and PhD in chemical engineering from USM. Currently, he is the chairman of the Center of Photonic and Advanced Material Research under University Tunku Abdul Rahman, Utah, Malaysia. Today, he is going to present the topic on application of photoremediation to remove pollutants from wastewater. Without further ado, I pass the floor to Dr. Stephen Lim.
Yeah, thank you. Thanks to the chairpersons, and thanks to the fellow colleagues from Korea and Singapore and all the AET members here. So I'm Dr. Stephen Lim, and I'm going to present this title today on the applications of phytoremediation to remove pollutants from wastewater. So can you show my slides? Okay, thank you. That's the laser pointer. Okay, so I'll start my presentation today. So the contents of my presentations. Okay, so my presentation outline for today basically will be covered first on some background and introduction about what is phytoremediation and why is it so important that we have to take note of that. And some problem statements about the importance of phytoremediations, its current development and status. And after that, maybe I'll go deeper into some of the research work that I've carried out in the phytoremediation field. So first of all, of course, we all know that the water's issues is getting more and more serious in our current situations. So not only just global warming, so water's scarcity issue is one of the important things. And with all the humans' developments and the industrializations, I'm sure we all know that the water pollution is something that we need to take more attention to. So undeniably, we hope that advancing the industrial development can actually help to solve most of the water pollution issue. But ironically, we also found that with more and more advanced industrial development, there's more and more water pollution occurring nowadays. So why is it so? So some of it is that we discover new threats discovered. So due to the new form of the pollutants that are coming out, and also increase in concentrations. Some previously the concentration might be too low to be noticed, but as more and more materials or chemicals being used, so this increase its concentration until it's reached a critical level. And also, of course, with advancement in technology, we have new detection and separation technique, which allow us to better separate this kind of chemicals or pollutants that are previously unknown of. So the three main emerging pollutants that I'm going to focus in this title. So there are types of emerging pollutants that are currently the main issues that we want to solve. One is the engineered nanoparticles. So if we know that there are a lot of nanoparticles now being used in various applications, and the continuous usage of these materials can actually constitute a water pollution issues. So the second one will be what we call as endocrine disrupting contaminants, so EDCs in short. So again, these are some of the dangerous contaminant as well, since it can cause a great effect even with a very, very low concentration. And the last one will be the persistent organic pollutants, we call it as POPs. So this can also be found everywhere, mostly in our life. So these are three main pollutants. So I'm just going to briefly introduce a bit of these pollutants. First one is the engineered nanoparticles. So as you can see, the engineered nanoparticles exist in a lot of different forms. We have those popular nanoparticles that have been used nowadays, like graphenes, multi-wall and single-wall carbon nanotubes, fluorines, and all these metal oxide nanoparticles. They've been used in a lot of different applications due to its higher stabilities, higher electronic conductivities, and better properties, mechanical properties, etc. So as time goes on, we believe that more and more applications will be going to use this kind of material. And if they are not being treated properly, they're going to discharge into our water bodies as well. And this can constitute as a new types of pollutions that we need to be aware of. If you look at these diagrams, you can see that the engineering nanoparticles, when entering into our aquatic bodies, it can produce a lot of different pollutants and can create some hazardous issues as well. Then the next one is what we call as the endocrine disrupting contaminants. So again, they can be found almost everywhere in our daily life, from personal care products, drinking waters, canned food, cleaning products, etc. So there exist available everywhere. So they have potential adverse effect even with very low concentrations, and can have delayed effects. So the one thing that is difficult to detect this kind of pollutant is that its effect might take up years or even affecting multiple generations due to its effect to the hormones, the body hormones, and also the response. So it can cause irreversible health damage, and lack of adequate tax method enforcement is the main issues there, where we're unable to detect properly in our wastewaters. Then there also one is what we call as a persistent organic pollutants. So again, this kind of pollutant is, as its name said, persistence is can accumulate in our whole ecosystem, and then it can bring toxics and affecting our human health and environment. So several characteristics of the POPs, you can see they possess toxic characteristics. That persistent in the environment means they can exist in a very, very long time without being degraded due to its high stability. It can bioaccumulate through the fish, the marine life that has been consuming all these POPs. They can then transfer into our human food chain as well. So it's one of the issues. And due to its high stabilities, it is prone to long-range transboundary atmospheric transport. So it can transport from one place to the others easily, and then can potential to cause adverse human health and environmental effects. So these are very serious issues. So one of the examples of POPs you can see is dioxins and furans and polychlorinated biphenyls. We use it to make our packaging materials. And those common pesticide and industrial chemicals all consist one or few of these persistent organic pollutants. So now, how are we going to address all these new and emerging contaminants? Of course, we still can use back our previous conventional treatment methods that are available, especially those advanced oxidation methods. But if you want to go towards a more sustainable and green technologies, we want to use the technology that won't bring great effects to our environment. So that's where we need to have a new types of treatment systems. So all the pollutants that things have in common is that basically they are not commonly involved in the routine monitoring of environmental samples. So that's why they are not that easily detected. I think so far that's very rare we have this kind of monitoring of these concentrations in our daily monitoring routines. And then they are usually existent in very, very low concentration. So that's why the detection have a very good, great trouble as well. But it still can cause a great harm to the various organisms in our ecosystem. And it's difficult to detect and even remove. And conventional treatment methods works, but it's either energy intensive or it's very costly. So, and some of the treatment methods like advanced oxidation methods, they might cause secondary pollutions and also not sustainable in the long run. So that's why in this case, we are actually touching on why we come up with this phytoremediation process, where it's a more sustainable and green technology to remove all these pollutants. So it's a phytoremediation basically is a plant-based approach where we use with the natural usage of the plants, we can use it to remove these kind of pollutants from the contaminated environment, either it's from soil or the water. So it works with many different types of pollutants. With the emerging contaminant as well, it has been found to be particularly effective because if they exist at low concentrations. So it can also limit the pollutant from spreading because using phytoremediations where we're using the plant to hold these kind of pollutants in a place due to it resistant to wind, rain, and groundwater flows. And of course, it has other advantages such as it's more sustainable and eco-friendly. It is basically using the plant approach, and the energy is come from basically from the sunlight. So it's very renewable and low cost as well. And it can be applied over wide areas. And when using a plant, of course, it can help to prevent erosions in our soil and improve the soil fertility as well. And one real example is you can see that the phytoremediation is being used where it used to clean up the Aberdeen Proving Ground in Maryland, USA. So this ground is previously used to burning those industrial and warfare chemicals back in 1940 to 1970s. But through the usage of the plantation of these poplar trees at the phytoremediation site, so that can actually reduce the contaminants up to 85% without any additional cost. Just by planting all these plants there as well, it can help to remove the contaminants already. So again, it can prove that it's effective over a wide range of areas. So there are different kinds of phytoremediations that we need to discuss here. So first is the phyto extractions, where we actually will uptake and recovery of those pollutants into the aerial parts of the plant biomass, means it's at the upper part. Then we have phytostabilizations, where we want to immobilize all these pollutants in the soil or water through absorptions in plant tissue. So phytostabilization is mostly at the lower parts of the plant. And then we have phytodegradations, where with the usage of certain enzymes from the plant, it can help to degrade these organic pollutants into non-toxic components as well. And then we have phytovolatilizations, where we actually convert those pollutants or heavy metals into volatile states where it becomes less toxic. And then we have phytostimulations. So again, due to the bacteria that exist in the soil as well, we can have a symbiosis effect where the microbial activity can help to degrade the pollutants together. And lastly is the resolve filtrations, where we're going to filter using the roots of the plants itself to filter those heavy metals or pollutants from the water by the plant roots. So on its mechanism, basically, of course, phytoremediation involves a series of processes in order to accumulate the pollutants inside the plant. So it consists of the pollutants mobilizations, the room uptake, xylem loading, root to shoot transport, cellular compartmentalizations, and sequestrations. So first, of course, the pollutants will be absorbed through the root surface of the plant and moved across up to the plant itself. And then upon entering the root cells, it can form complexes and then can be immobilized in the extracellular space or the intracellular space of the plant. So then the metal ions or the pollutants will be sequestered inside the vacuoles, the plant cells, and then transport into different parts of the plant through the xylem streams. And subsequently, they will be transported and distributed in leaf or the other parts of the plant itself, and then can be sequestered easily in the extracellular compartments. So these are the main mechanisms that are happening in the phytoremediations. So on the current status, so basically phytoremediation has been ongoing research for decades, and you can see currently we have a lot of different countries already quite actively contribute to this field, and also the publications regarding phytoremediation has been increasing through the years. So we have gradually evolved from the discovery of hyperaccumulated plants. So hyperaccumulated plants means that those plants that can accumulate these pollutants very fast in a very swift and very large amount. So that's why they're called hyperaccumulated plants. So from the discovery of hyperaccumulated plants, now we already focus more to the internal growth and development mechanism in order to understand better how the plants works to actually extract all these pollutants. Then also we are studied on the seed germinations and the seedling growth characteristics so that we can better improve on the phytoremediation study. And we also have studies exploring on different alternatives or how we can further improve the effects of the phytoremediations, where involving the externally applied electric field in order to remove the ions, and also how we usage the microbes effectively in the soil itself so that we can help to improve the phytoremediation efficiency. The large-scale application is also being studied continuously through constructed wetlands, where the large-scale process is more feasible and can be remove a lot of contaminants through these constructed wetlands. So on the issue of constructed wetlands, so this is more, we are talking about the large-scale phytoremediation applications. So phytoremediation modules that use in the wastewater treatment installations basically will be designed wetlands which containing aquatic or marsh plants. So there are different types of flows that allows the constructed wetland to work. So generally, the constructed wetlands will consist of a reservoir, a suitable filler materials, and planted vegetations. And the contaminated water can be introduced depending on the different types of flow here. As you can see, we have different types of flow. So I'm not going to go into details, but each flows will have different advantages and disadvantages. And then at the end of the process, it will be expelled from the constructed wetlands, and this will be the clean water that we're talking about. So the constructed wetlands, basically they're employing floating aquatic vegetations. So, or they can also employ as a chain of several ponds with a primary stage of mechanical wastewater treatment. So that can actually be coexist with our current conventional wastewater treatment process. So to replicate the natural conditions, so we can actually achieve optimal remediation of contaminated water, and we can actually employ a combination of plant species. So not necessarily just we use one or two specific one, we can have a combinations that can actually targeted to a wide range of pollutants together. And this can create a synergistic effect within the same system and be more efficient. So advantages, as you can see, basically it's very cost effective. Once you have these plants ready, basically you just need to monitor its growth and replace if necessary. And basically it doesn't require a lot of maintenance. You can just leave the plants to work by itself, and then it has a high ability to remove those pollutants. Okay, so these are the introduction of the phytoremediations. Now a bit of the info of my current research on the phytoremediations. So basically this is one of my projects which we are focusing on removing the nickel 2 ions, which is a popular heavy metals in the industrial wastewater. So we want to see how we can remove these nickel 2 ions through phytoremediations. So we embark on this research is due to the ineffective of the conventional techniques for the heavy removal methods. And then the uptake abilities of various species on these nickel ions is still quite unknown. So we want to explore further. And then we also want to investigate different potential of the accumulator plants that we are targeting. And we want to investigate the uptake abilities of these various species floating aquatic plants towards the removal of nickel ions. So these are what the few methodologies that we're using, the plant preparations, and we prepare the synthetic wastewater containing the nickel ions. And then we studied the different parameters. So we also do some characterization study, data analysis, and lastly, we go to the kinetic and isotherm model studies. So due to lack of time, I'm just showing some of the important results that we obtained. So basically, we are testing with 4 different kinds of aquatic floating plants in our studies to remove the nickel. So even you can see that each of these plants basically containing quite a high removal efficiency. Those, for example, for Salvinia natans, which is quite a popular floating aquatic plant in Malaysia. So it can reach about 90% removal efficiency already. So even without comparing to conventional chemical treatment, this is considered quite effective. So the nickel 2 ions uptake ability from these 4 different species we discovered. So Salvinia natans basically is the most efficient one. And then we look at the bioconcentration factors, where we actually measured the metal ions concentrations inside the plant and compare it with those in the surrounding medium. So the higher the bioconcentration factors, it means that it can absorb more ions into the plant itself. So here you can see that Salvinia natans basically has a very high concentration factors. So it's indicate that it's very suitable to use to absorb these nickel ions. So we also done some characterizations where before and after the phytoremediations, we discovered that there are spherical particles attached to the surface of the roots. So this shows that the nickel ion has been absorbed successfully through the roots itself. And then from the leaf, basically don't see any significant difference. So that means that it doesn't really transport out from the leaf of the plant itself. And then on the effect of nickel concentration, we varied with different concentrations. And again, we found that the best concentration that it works will be under 4 milligram per liter. So of course, higher concentrations will result in the poisoning of the plant growth as well. So this will be the limit that the plant can take for the nickel concentrations. So the removal efficiency basically increased with increasing initial nickel 2 ions, and no further increment when reaching the optimum point, which is the 4 milligram per liter. And high nickel levels above 4 milligram per liter, we found that it has this oxidative stress, and then it affects the membrane permeability of the plants. So it resulted in that the resorption to the plants, the transport mechanism will be inhibited. So this causes lower plant uptakes. And then also we want to investigate the effects of these ions to the plant growth itself. So we don't want the plant that are unable to grow due to after absorbing all these pollutants. So from here, again, we found that basically Pistia stratius and Salvinia natans show negative growth rates. Although Salvinia natans absorb quite a lot of nickel ions, but at the same time, its growth rate is quite severely reduced. So negative growth rate basically means that it has a significant impact on the plant metabolisms. And while the other two plants basically have a positive growth rate. So positive growth rate means it's actually an exotic plant species, means it can perform the phytoremediations more effectively within a short period of time, while it still be able to grow its plant biomass. So on the quality of treated water, so again, we measured the COD value of the treated water. Basically, it fulfilled the requirement of the Malaysian standards under the industrial effluent discharge standards. And then when we look at the days of the COD removal efficiency, so it started to increase due to the phytoremediation of the plant. And after day 6, basically it reduces a bit. So we found that it's due to the plant which started to decompose and then release the organic carbon components to the plant. So at the same time, we also want to find more stable plants that are harder to decompose so that we can retain the pollutants more inside the plants. And these are the kinetic models that we have investigated in order to study further how we can further improve the kinetics. So basically, it's a pseudo second order kinetic models. And then on the isotherm model as well, we discovered that friendly isotherm models fit best to describe the phytoremediation process. And as a conclusion from this study, it shows that Salvinia natans exhibited the highest removal rates, about 91.3%. And these are the optimal cultivation conditions. Of course, further study will be needed to address the negative growth rate of the plant that we mentioned earlier. And for the potential of phytoremediation in general, so basically, phytoremediations can actually remove those pollutants using plants from a few percentage to almost 100% with the nickel ions that I shown you earlier also. So it basically depending on the types of plants you use, structure of compounds, concentration, and also the plant density. So what makes this attractive is basically is a simple process, low cost, and also particularly effective for developing countries. So, but of course, it has its drawbacks where it's a time-consuming process. If you need the plant to remove a lot of these pollutants from the contaminated site, so it takes quite a long time to do as well. But of course, with further advancement in technology, we believe that this can be sped up. So of course, we have to look also at the ancillary advantages of the phytoremediation applications. Like for example, the plant growing after that we can actually use the biomass created into other types of biofuel process. And even now, our research group also studying on how after extracting all these pollutants by the plant, how we can actually extract this pollutant from the plant itself and reutilize it in other areas. So these other ancillary advantages that we can see from this phytoremediation process. So of course, application of genetic engineering approach is one of the way where we can further improve the phytoremediation efficiency. And further understanding on the mechanism will be important in order to actually fulfill the maximum efficiency of the phytoremediations. And also, study of chelating agent and microorganisms can help to improve its efficiency as well. So these are basically the future directions that our research group will be working on. Yeah, and that's our reference. And yeah, that's all for our presentations. Thank you.
Thank you very much, Dr. Stephen Lim, for the interesting topic. Just happened that 20 years ago, I did my master in constructed wetland, also very similar. I did on the landfill leachate treatment. Yeah, later we can chit chat more on that. Okay, next, I would like to invite our next speaker, Dr. Yong Soo Song, the Vice President of Green Tech Korea. The topic of his presentation is on development of a non-power gravity-driven water treatment system using an electrospun nano-flat membrane with a 3-dimensional structure. Okay, without further ado, I invite Dr. Song to present his topic. Thank you.
Thank you. Selamat pagi. Thank you very much. And good morning, everyone. Already he introduced me. I'm Yong Soo Song, Vice President of Green Tech in Korea and South Korea. My today's topic is development of.
예, 들으세요. 예, 예. 예, 들으세요. 예, 예, 예. 예, 들으세요.
Can we mute our virtual participant?
Okay. Yeah, my today's topic is development of non-powder gravity-driven water treatment system using nanofiber, electrospun nanofiber flat membrane. First, we look at some current status of drinking water and the water treatment systems. And I will introduce the GD nanofiber membrane and the GDM water treatment system. And finally, I'll show you some verification, field verification data in Korea, domestic area, and also in overseas, like in Indonesia and something. Oh, it's the old one. Okay. Yeah, I'll use this one. Yeah. Anyway, there is just some limitation in Baguio, like for supplying some drinking water or etc. In the place, usually they are using the chemical treatment and the physical treatment, and in some case boiling water process they are using now. Anyway, in the case, it's some difficult to remove some waterborne pathogens like bacteria or virus. Yeah. So anyway, we must find a way to overcome the technical problem, like insufficient infrastructures, and also we must find a way to overcome some kinds of maintenance problems. Yeah, already Dr. Sang-Yeob Lee said using membrane filtration in the case needs a very high energy. It's a high energy intense process. So in the case, it's very difficult to, especially for the place like insufficient infrastructure areas like that. So I introduced the non-powder GDM water treatment system. GDM means gravity-driven membrane. Without electricity, we can purify the water. Yeah. So we need this is low water. We need some kinds of GDM filtration tank. Inside, we installed this gravity membranes. The principle is like this, only by the gravity. Gravity means the hydrostatic pressures between the gravity-driven membrane and the water level. Yeah. So using this is the GDM filters by gravity. Yeah, some source water in the case we can get some clean water using the GDM filters. Yeah. Next, I will introduce more in detail. Yeah. Our target is, I will summarize three parts. One is the development of electrospun nanomembranes. And second one is using this electrospun nanomembranes. We developed the membrane filtration systems like a GDM. And in some case, depend on the low water, we need some kinds of pre-treatment or some case post-treatment. So based on our GDM filtration systems, we can add some kinds of systems between or fast. Yeah, depend on the low water. So this is nanofibers. Nanofiber, usually we can say the nanofiber means the diameter is below 1 micrometers. It's, usually several hundred nanometers, and long fibers. Shows a very high surface barrier and small pore structure. You can see the human hairs is the diameter is 0.1 millimeters. You can see the white area backside of human hair. This is SEM photograph. It looks like some kinds of net-like. Yeah. So this diameter, nanofiber diameter is around already I mentioned several hundred nanometers, and the pore size also up to 1 micrometers. So this is a net, net-like. So it means that using this kind of nanomembranes, we can filter out something and pass this nanofiber membranes like water. So our idea is like this. yeah, first one is we must filter out some kinds of pollutant. Yeah, so in the case we need a very small size of pore size, and but we need more quantity. So in the case we need a more high porosity. So using this kind of nanofiber membranes, we can get a yeah, like this filter out very small contaminant particles, and also allow large amount of water or pass through. Yeah, the porosity is more than 80% in this case. Yeah, so you can see the various kinds of nanofiber membranes using various kinds of manufacturing systems. This is the nanofiber membranes made by electrospinning process. Yeah, I can say to you, the nanofiber membranes made by electrospinning process in the case optimized for the GDM water treatment. The GDM means without electricity, you can purify some kinds of water. So as you see, using nanofiber membranes have many kinds of benefits. Yeah, so like features like the narrow pore size distribution, and the porosity shows more than, yeah, generally 80% more than, and also the next I will show you the excellent. We can easily remove some kinds of bacteria or some virus. Yeah, in these figures you can show the very narrow, very uniform distribution of pore size. Yeah, already I mentioned the electrospinning process. Electrospinning process, I think you know, electrospinning process is applied some high voltage to liquid polymer solutions, and then we can get a fine jet from the needle of this kind of syringe pump or something. Yeah. So our company started this kind of R&D from around 20 years ago. Yeah, please show the. Yeah. Okay. Sorry. Oh, sorry. There is just some kind. Yeah. Anyway. Okay. Yeah. Anyway, we set up some level scale, and the pilot scale means just usually 1.1 we put the width is, and also we can set up the lines. We can produce the nanofiber membranes. The width is 1.7 meters. Like, yeah, this is the final product like this. To make some kinds of nanofiber membranes, first we must select what kind of material is best for the GDM filters. So we tested several kinds of material like PDF, PVDF, PAEN, some case PEPS. So you can see the structure of tensile strength and elongation. So you can, yeah, in this slide you can see the PVDF pan shows better property compared to porous film structure, and also if we can compare the strength and the elongation and the oxidation resistance and the chlorine resistance. That's why in low water, some kinds of materials like chlorine or something. Yeah, so we can say the PVDF shows better property compared to PAN and PE or some kinds of other materials. So we select the PVDF materials to make some kinds of nanofiber membranes. And also to test our nanofiber membranes, we work together with the Nanyang University in Singapore. So we tested in Nanyang University, Singapore, and you can see the water, in record, the porosity is more than 80%, and most important thing is the amount, the flow rate. So flow rate is much higher than you can see here, the compared to existing membranes, 6.6 times more higher than, and also you can see some other data here. And also, our target is appropriate the nanofiber membranes. So in the case, we must find them. We must make many data for making and some case maintenance. So you can see, depend on the pore size we tested, and depend on the thickness of nanofiber membranes we tested. Yeah, mainly we tested 2 points. One is the flow rate, and the second one is the removal ability of bacteria or virus. As a result, we could find the pore size is around 0.3 nanometer. In the case, shows a very high, better the filtration flow rate. Yeah, and in this case, we can explain according to the membrane fouling models like this. For first, depend on the pore size increase, but more above 0.3 micrometer in the case slowly down. So we can explain this kind of phenomena, using the membrane fouling models like this. And also, already I mentioned, most important thing is the removal of bacteria. So in some organization, they tested, depend on the materials PVDF, and the pore size is 0.2 nanometers, 0.3, and 9 GSM means I can say that the thickness of the density of nanofiber membranes. So anyway, we tested. So 0.39 GSM membranes can remove the almost the bacteria or something. So we decide our nanofiber membranes, the pore size is 0.3 micrometer and 9 GSM. As a result, basically the standard model is like this. From the flow rate is around 4.2 to 84 liter per hours. It's bigger, like this. And so we test using our systems. We tested the filtration capacity. So this is around 6 months without cleaning. So we can find more than 3 times higher filtration capacity compared to existing nanofiber membrane, existing some kinds of purifying systems. And also, the maintenance and the repair is very important for commercialization. That's why there are not many experts and something. So we must find a way to clean and repair very easily. So we want to make some kinds of standard to cleaning and some kinds of repair. So we tested many kinds of cleaning systems, like physical cleaning. Physical cleaning means only by air, and some kinds of the physical cleaning systems depend on like this. And and as a result, we found only, you can hear, the good cleaning effect just by simply washing the surface with high pressure, some kinds of watering, and some case air. So in this case, you can see here. And also in the case of the high turbidity water, so like this, the after rain or something in the case also shows a similar properties, and using very simple physical cleaning, we can find some recovery by the physical washing is around more than 95%. And in some case, depend on the low water, we must customize our process. Basically, mainly in low water, including some kinds of heavy metals like arsenic or some kinds of heavy metals. This is the existing way to purify the water. So in the case of arsenic, in the case we can add some kinds of process like the electrocoagulation systems, and in some case using some coagulant. And then based on our systems, we can purify some system. And we check the coagulants and some EC. In the case using the coagulant like aluminum salt or iron salt, we can find some, like this. After that, using this kind of coagulant, we could see some recovery of the water purified systems. And also we check the arsenic removal using coagulant, like already I mentioned iron salt or aluminum salt and the issue. Yeah, depend on the contents of iron salt. In the case you can find the removal of arsenic, some metals or arsenic component. And in the case of depend on the voltage, amount of voltage also show the same phenomena. So usually I can say that the efficiency is in the case of EC is more effective. It means that very easily you can remove the arsenic, etc. And finally, I would like to say about the field verification in Korea and in overseas. Generally, our verification, field verification is doing together with the Korean, Korean water. It means the government organization about to treat the water and wastewater something. So in the case, in this place, some problem is depend on the after rain. So the turbidity changes. So in this case, no problem, but after rain, some problems. So using our systems around more than 6 months, we can find the turbidity is the flow rate is above the target. Shows the target is 10 liter per minute hours. So we show the 15, and turbidity is from 0.2, and we cannot change it very below. It means that. And also we tested this is K water, the emblem, and we checked the removal of bacteria. So you can see all kinds of bacteria we could not detect it. So final result is this is a Korean word 적합. It means suitable for drinking water. And the second one is near Seoul is Gyeonggi-do areas. We tested. This is we made some GDM unit production and installation, and finally we installed the real-time water quality, real-time monitoring system. So we checked many kinds of more than 9 items. We checked the turbidity, filtration flow rate, or something. So we could find turbidity is very low, and also filtration is high, and bacteria around 100% not detected like this. And also for overseas, we made 2 kinds of our systems. One is small systems. Small system is around the more than 30 liter per day, and the large system is more than 100 liter per day. We prepared the 2 kinds of systems, and when this is overseas in Indonesia, I remember the North Sumatra, Pekanbaru. Do you know? Maybe Pekanbaru. Yeah. Those Sumatra. So we test in this area. We test a small system and large systems. Already I mentioned 2 points. One is flow rate and removal of bacteria. So we find you couldn't distinguish it, but anyway, we could find the removal of bacteria, and the flow rate is above our target flow rate. And also in Uganda and Myanmar and Tanzania, we tested our small systems. Also, we checked the removal of bacteria and the flow rate. Yeah, every case, we could gather the satisfactory data from that area. This is our module. So I prepared the picture, the movie. Yeah, please. Yeah, okay. Yeah, this is a real water is very true. Already I mentioned is around 4 to 5 liter per hours, the small systems. And also I prepared some brochure, so please use it. Anyway, thank you for your listening, and I hope, I will look forward to more strong cooperation with the AAET and NAEK. Thank you for your listening one more time. Terima kasih.
Thank you, Dr. Yong Su Song, for the interesting presentation on the gravity-driven membrane. Please reserve your question to the Q&A session. Just for your information, we will take a group photograph after we finish all the session. Please stay with us until the end. Okay, next, I would like to invite our Professor Yang Hui-Ying. Is Professor Yang already online?
Yes.
Professor Yang Hui-Ying is with the Engineering Product Development, Singapore University of Technology and Design, SUTD, Singapore. The topic of her presentation today is New Generation Low-Dimensional Nanomaterials for Advanced Energy Storage Devices. Okay, I pass the floor to Professor Yang.
Thank you, Chairman, and thank you for the colleagues. It's my great honor to be here today to present to you my research related to the low-dimensional nanomaterials and their applications for energy and water. As we all know, there is a very important topic on net zero emission, and it refers to use renewable energy and then reduce the carbon dioxide emissions from every sector in the industry. Singapore aims to achieve net zero emission by or before mid-century. To achieve this, the energy used in water treatment need to be largely reduced. So let's review a little bit the current energy that being utilized for desalination and water treatment. There are a few group of technologies have been utilized for energy, for low energy or high energy sort of concentration of water treatment. For example, the first group is membrane technology. So there are like different type of membrane, for example, reverse osmosis, electrodialysis, and then so on and so forth. And those membrane are actually very expensive due to the huge energy and infrastructure cost. And then the second category of water treatment is the thermal-based water treatment system. So most of these thermal methods need additional facility and then also heaters, pumps, and so on and so forth. And then there are like promising technologies in the alternative treatment or alternative technologies for water desalination or water treatment. In this group, we have microbial desalination, capacitive deionization, and then ion concentration polarization, and so on and so forth. And those low energy consumption water treatment technology aim to reduce the energy consumption in water treatment to below 3 kilowatt-hour per meter cube. Our group are actually working in the low energy water treatment and desalination technologies. And today I will present some research work on capacitive deionization. Capacitive deionization is a very simple process. It refers to use two electrodes. One is being positively charged and the other one is being negatively charged. A very small value of direct voltage or current will be used to charge the electrodes, and oppositely charged ions are absorbed onto the electrode surface because of the physical attachment. And electrodes are regeneratable by a short circuit motion or reverse voltage current. So from the figure on my right hand, you can see that there are different ion content concentrations in seawater or salty water. For example, below 1,000 and below 10,000 or below 100,000. So for the water with ion concentration above 1,000 ppm to below 10,000 ppm, we can actually utilize reverse osmosis and method. For the water with ion concentration above 100 ppm, we can only utilize our thermal method to evaporate the sort of water and get the true water from such high concentration, ion concentration water. And then for the water with ion concentration below or slightly above 1,000 ppm, there are different approach for that. For example, NAEK softening, EDR, and so on and so forth. And then for water within like 1,000 ppm, sometimes like around 500 ppm or below 500 ppm, we can actually utilize our like CDI or like some similar method to do the water treatment. Since the starting of our research group, we start to look for new materials for the electrode for capacitive deionization device. We can see that there are like many criteria for a CDI electrode material design. So for our group, we have summarized there are 5 main sort of criteria for the high efficient CDI electrode material. For example, high electrical conductivity, large surface area, a favorable precise distribution, good wettability, sufficient ion diffusion pathways, and so on and so forth. And there are like very dynamic modeling approach for the CDI precise as well. For example, you can modeling the CDI like a precise based on the voltage distribution, initial condition, computation for surface charge density, and so on and so forth. And then with this like criteria, we actually have shortlisted the carbon nanofibers, graphene, and also the 3-dimensional structure with a carbon hollow structure as electrode for this CDI device. However, even with those very high efficiency for capacitive deionization sort of material, we can have barely around like 10 to 20 milligram per gram absorption capacity for CDI devices. And the reason for that is that we may have this sort of very limited capacity only based on this physical attachment of this certain positive or negative charge on the surface of the electrode. If you want to further improve this efficiency, you need to prevent the cation being absorbed by this anion electrode. When you have a large amount of anion being attracted on the surface, which is called cation expulsion effect. If we want to reduce this cation expulsion effect effectively, we need to enhance the salt absorption capacity, improve the energy efficiency, and then have a bettering performance for this electrode. What we have done is we actually implement a membrane, ion exchange membrane in front of this electrode to prevent this cation expulsion effect. So you can see over here we have a sort of implement one anion exchange membrane before this sort of porous carbon electrode on the like a cathode or anode for this sort of electrode. And then after we have this anion or cation exchange membrane, we can see that our efficiency has been greatly improved for this membrane-based CDI device. After that, we actually can move this sort of salt remove capacity from like 10 to 30 to 40 milligram per gram salt removal capacity. But again, this is still a very minimum level of salt removal capacity. If we want to improve this salt removal capacity a little bit further, we need to actually fundamentally change the absorption capacity by this from this like purely physical based attachment for the ions to the electrode to some sort of chemical based reaction or absorption. So what we have done is that we actually have our new desalination design based on a hybrid asymmetric sort of CDI design. So on the carbon-based materials, we can choose, for example, activated carbon, CNT, or graphene oxide-based material. And then, of course, we know that the limitation we have for such carbon-based material is a low removal capacity. And then for the hybrid asymmetric CDI system, we can have the intercalation electrode for sodium ions. And then the absorption carbon material for chloride removal and intercalation electrode for sodium removal. Based on this, we have a capacitive material with suitable intercalation layers, for example, methane and nanosheet material. So sodium-based metal oxide with intercalation channels, and so on and so forth. With this, we can actually enhance the ion removal capacity with optimized CDI system design, low cost energy saving precise, and then synergetic effect for counter ions on the opposite charged electrode, and effective ion swapping at the electrode interface due to the counter ion inserting and co-ion discharging precise. With this, we can actually largely improve the salt removal capacity. But again, what we want to do further is that we can have this hybrid capacity deionization. And one step further will be purely based on electrochemical approach for both anode and cathode. So we can see that we move from this original capacitive deionization device to membrane capacitive deionization precise, and after that hybrid capacitive deionization precise, and eventually electrochemical deionization precise. We enable the enhanced ion selectivity towards only sodium or only chloride, and favorable towards seawaters with high salinity level and multi-ion compositions, high degree of freedom in terms of forms and scalability, and also free control of the desalination energy storage capacity with smart design for nanomaterials. And we can also have this nano switch obtained with precise crystal configuration and vacancy control in this 3D structure for this ion sort of selective electrode. So with this, we actually design our mechanism, which is called desalination battery. So this desalination battery, the pure purpose, the original purpose is to desalinate the water, desalinate the seawater by an electrochemical process. But then when we have the electrochemical reactions for both anode and cathode, we realize that we can actually release those ions out when we want to realize or sort of start the process. And in this releasing process, we actually release the ion, also release the charge, and this is actually a battery sort of function. And then therefore we name this process or this device as a desalination battery. With a desalination battery, we can actually remove the sodium and chloride with a capacity more than 100 milligram per gram, have an energy recovery rate more than 30%. We can have a very minimum level of energy consumption of 0.12 watt-hour per gram, have an energy consumption or recover controllable by applied voltage. And then we can actually have both sodium and chloride have this intercalation reaction with the electrode. For example, we can have the electrochemical reaction for sodium, which you can use NMO based material. And then for chloride, you can use a bismuth oxide based material. And with this, you can actually realize desalination by removing sodium and chloride, and also generate electricity or release those ions when you discharge this desalination battery or desalination generator. Our future goal is that we want to realize a desalination battery use electrode to engage in specific reactions with sodium and chloride. Seawater function as an electrolyte, and desalination can be analogically treated as charging a battery to store sodium and chloride ions. And then the sustainable and low-cost solution to meet the society need for both water and energy. We can actually utilize the same principle to remove other ions from seawater, not only sodium and chloride, but more than that, for example, lithium. So the lithium can be extracted by a fluidic electrochemical system based on this seawater desalination or like ion removal in this seawater, seawater sort of fluidic device. So lithium is very expensive. We all know that seawater actually contains more than 5,000 times as much as the lithium supplies on the land. So the current limitation we have is this lithium concentration is too low, is actually less than 0.17 ppm. So we design a 3-chamber system with like 2 steps. First step, we actually have this lithium inserted into this manganese oxide electrode material. And step 2, we oxidize the manganese oxide, with lithium back to manganese oxide. And then after that, we release the lithium and reduction the oxygen to form this lithium hydroxide. To highlight over here, the lithium hydroxide is actually the material that we eventually utilize in the production and generation of lithium ion batteries. So with this, we can see that the delta G towards different materials are very different. Very differently, and then we can see that with this sort of laminate manganese oxide, the delta G is actually highest for this lithium ion, which shows the material have a very high lithium selectivity. And then also we can see that the insertion potential is also highest for lithium, which it means that the lithium can be inserted into the system with many different competing ions, for example, sodium, potassium, and so on and so forth. The ion insertion performance also governed by the velocity and diffusion coefficient. That's why you can actually control the lithium diffusion rate by utilizing different sort of fluid rate to generate a different diffusion coefficient. Lithium recovery in seawater is actually very challenging. For now, we actually can targeting at like seawater concentration with sort of concentrate seawater with 7 ppm as the lithium concentration. And then the capacity for our electrode can be 20.6 milligram per gram within like 45 minutes this extraction time. And then also we can also targeting at other sort of ions more than lithium. For example, we can also have this sort of sodium or potassium and other ions being selected and being sort of like inserted into different electrode material. For example, we have have a monovalent cation removal precise or cation collection precise with this graphene oxide membrane. And then within this graphene oxide membrane, we can targeting at monovalent ions versus these divalent ions. So we can actually have these sieving ions, sieving precise targeting at the potassium ions, and then also sodium ions. And then we can see that the monovalent versus divalent ion cation removal precise is very differently. You can see that these monovalents can be sort of only removed by this EDA-GO graphene oxide kind of electrode. The selectivity of our potassium is as high as 4.2 versus magnesium, and the selectivity for like sodium can be as high as 3.4 times when this mix this manganese together with those sodium ions. We also remove the boron from seawater by this nitrogen-doped graphene oxide. We know that WHO actually recommended 2.4 milligram per liter boron concentration for drinking water. In Singapore, we have 0% requirement for boron in our drinking water. And then the seawater actually contain this boron more than 4.5 milligram per liter. And we know that boron is actually very, very small. So it's very hard for the normal membrane to totally remove this boron. So what we have found out is boron actually exists in the seawater by the formate of boric acid. And then this boric acid actually natively have this negative charge, and the nitrogen-doped graphene oxide actually have a positive charge. When this nitrogen-doped graphene oxide meet this like a boric acid, the positive charge and negative charge will attract each other and then have this one water molecule being reduced when these two OH group meet each other. And from there, they can generate a permanent sort of chemical bond between this boric acid and then this nitrogen-doped graphene oxide. And then from this, you can see that the specific chemisorption occurs when this hydrogen bonding and donor acceptor interactions between this OH group like form this boric acid to borate anion like a group from NGO. And then there are totally 9 possible complex have been identified, may having this sort of nitrogen doped in different locations for this sort of nitrogen doped graphene. We found out that the highest chemical bonding energy occurs between one quaternary nitrogen atom and then 2 adjacent hydroxy groups that this combination for this nanocomposite. And the boron performance for NGO is actually 23 times higher than pure GO. And then the boron rejection rate for NGO is 5 milligram per liter. Boron concentration as high as 91%. The boron absorption capacity for the NGO is 23 times higher than pure pristine GO, and then boron absorption capacity in seawater condition can be as high as 58.7 milligram per gram. We can also utilize the NGO for recycling other heavy metals like antimony. We have been working on the NGO remove antimony for reuse those antimony for sodium ion batteries, so that we can collecting the antimony and also reuse for energy storage purpose. The rejection rate for antimony recovery can be more than 95%. At the sort of application for our ion selective system or ion removal system, we can see that in the future, we can actually utilize those ion removal, ion selective system in pharmaceutical applications, wastewater processing, precious metal recovery, agriculture, drug delivery, and so on and so forth. I believe there are a bright future for such technologies in many industry sections, and our research will be contributing significantly for net zero emission, low energy sort of utilization for water treatment and water desalination. With this, I want to thank my founding agency, the Singapore National Water Agency, PUB, National Research Foundation, and my research team members. And thank you all for your attention. And hopefully we can know each other through this platform and build up some collaboration for the future. Thank you.
Thank you, Professor Yang, for the interesting topic. So next, we will invite our moderator for the first session, Professor Park from Department of Civil and Environmental Engineering of Hanyang University, Korea. The topic of Professor Park's presentation is Trends and Prospects of Water and Wastewater Treatment in South Korea. I pass the floor to Professor Park.
Good morning, everyone. My name is Jae Park again. If my presentation is ready, then I will start. Okay, actually, the title of my presentation is the trends and of the water and wastewater treatment in Korea. I hope this can be sort of the food for thought for our future cooperation between NAEK and AAET. This year, we started our water treatment group, and we had 2 online seminars, so we get to know each other better. So I want to sort of sum up what we have done this year, and then I want to show you what we think we can go forward, where we can go forward. Okay. Okay. They are opening up the file. Just yes, thank you. Yes, again, that's the title of my presentation. And first, let me introduce myself. My name is Jae Park. I am an environmental engineer trained in civil engineering department. I started with subsurface remediation, soil and groundwater remediation. And then last 17 years, I was lucky enough to get support from the government research agencies. And I started work on the nanomaterials for the water and the subsurface remediation. The material I worked on was magnetic coat dendrimers. And then recently I moved on to the nano-sized photocatalyst. So I'm working on the rather water treatment field recently. Okay, today I'm going to talk about these contents. First, I'm going to talk about the water industry worldwide and the South Korea, and then advanced treatment, trends and prospects. And then lastly, I want to show you where we can go together. Yeah, some of this information was briefly shown by Dr. Lee this morning. Water is a problem and becomes a different problem than before. As you can see here, 40 billion people need more water, and more than 3 billion people, they rely on the transboundary water. They get the water from the outside where they live. And 2 billion people depend on the groundwater, droughts, floods. This many people are affected. These numbers are much more than what we used to see. And also we have traditional problem as well. 80%, more than 80% of the wastewater is not treated and then released into the environment. Yeah, some of these problems was due to the climate change. And so all over the world, Korea as well, we are trying to transit water resource management to respond to the global change. So the water scarcity is shown many different parts of the world. Korea is one of them. And we are seeing more water disasters. So we are not try to cope with these disasters. So water resource management strategy is new. We need to go for the new directions. First, we have to secure new water reserves. We need more water. We need to find where to get the water. We need to enhance the efficiency of existing water resource facilities. Water resource facilities where water intake or water treatment, wastewater treatment is a big facilities, and it's not easy to modify. Once we have it, we'll have it 30 or 40 years. And but the problems are more recent. So we need to find a way to enhance the efficiency of these existing water resource facilities. And also we need to do the digital transformation, which was well introduced by the Dr. Lee this morning. So these are the new directions in water resource management. Recently, Korean Ministry of Environment newly defined the water industry as the projects and related services that encompass the entire water circulation. Used to be when we talk about the water industry, we confined ourselves water and wastewater treatment. So these are the old picture, conventional water industry, OECD and World Bank, but the new water industry should include new field, water storage, river management, and groundwater. So something we haven't talked about before should be included in water industry. So these are what we're trying to do in Korea. Globally, it's the same trend. Global water industry market is expected to grow and reach 10.2 trillion by 2027, which is about 35.1% growth in water demand in 2050. And also we'll see some decreased water supply. So global market will increase 4%, which is higher than any other industries. So water industry will be bigger. It's global number. And Korea as well, water industry, we think, we saw some growth from 2017 to 2021. The market size is grows, and we have the same problem. In addition to that, the water market infrastructure in South Korea faces saturation, making substantial growth challenging. We filled up our capacity, but we didn't meet our demand. So we need to do something new, and we find a way to modify what we used to do. Also, creation of the new market is necessary. Water reuse, desalination, groundwater, water-related energy, river management. These are new fields which we didn't pay attention enough, but we should pay attention more. Currently, Korean infrastructure numbers are like this: drinking water and sewage treatment, which does not include the industrial wastewater treatment. Coverage numbers are 99%, 99% or 94%, pretty high. But the problem is, it's old. It's old. It's more than 20 years old. So pipelines becomes old, and treatment facilities becomes themselves they are old. Also, sewage treatment, the pipelines are old, so we need to upgrade them. So we have double problem. We are facing the new problem, which is securing the water demand. Also, the old facilities should be revamped and redesigned and invested. So if you look at the Korean water treatment development stages, we think we are around this stage, third or fourth generation. So we went over sand filtration, disinfection, river water groundwater use. We accomplished in some parts enhanced disinfection. In some parts we did the advanced treatment, but we are still around this stage. Hopefully, we can go over to trace contaminant, and algae treatment, which we haven't reached yet. In terms of water treatment, this is where we are. In terms of the sewage treatment, we are around second and fourth generation. So in some parts, we do organic matter treatment, nutrient treatment. We also do some sludge reuse. But when you talk about the trace contaminant, as Professor Lim pointed out, we are not doing a very good job. I'm sure I think it's pretty much almost the same all over the world, but we are at this stage. So in order to go over where we are to the next generation, we need to do some more work. But still, another problem we have, I should say just current status, large-scale facilities, when we revamp our original facilities, we still depend on the overseas products. Worldwide, big name players for the ozone or membrane, they produce very large facilities, and they have better experience. So in a way, they have competitive edge. So in order to overcome that, we need to do some more work. So as you saw in the status of the water and the wastewater treatment in Korea, advanced treatment is some common words. That's something we have to work on. Globally, advanced treatment, if you look at the market and the players here, they see the market will grow. Market will grow by 2027. It will reach 3.55 billion USD. Driving factors are market driven by the increasingly stringent regulation all over the world. The regulations becomes more tougher and tougher. In order to treat those contaminants, we need something strong. That's why they rely on these technologies. Market dynamics, high demand for the advanced water treatment technologies attracted new entrants to the market, and especially UV, ozone-based AOP are the front runners of this market transformation. If you look at this graph, these are the players, larger players, Trojan and some companies, and these blues are the ozone. So ozone market is leading in AOP, while the new entrants here. So this is current. I'm not saying that ozone will be the permanent number one player. It may be changed, but this is where we are all worldwide. In terms of the AOP, this is very good to treat the non-biodegradable organic contaminants because they require strong chemical treatment other than what we have right now. These are the oxidants where we are using hydroxyl radical, singlet oxygen, and ozone. These are the oxidation strengths. If we can have hydroxyl radical mostly, it will be very strong. But in some senses, we cannot have them. We rely on ozone and we rely on the other oxidants. So prominent AOP methods include ozone, phantom, and photocatalyst. And these are the major players, which is also shown here. Okay. And when you talk about the Korea, Korean Ministry of Environment strengthened non-biodegradable organic contaminant standard for industrial wastewater by introducing TOC in place of the COD. So COD it has been traditionally widely used, but we replaced COD with a TOC, which requires stronger treatment, which has to oxidize everything. So this is one of the driving force for the new AOP technologies worldwide as well as in Korea. AOP different methods, whether it's homogeneous and heterogeneous, there are various methods. So these need to be more developed and more worked on. When we have seminars a couple of times this year, I saw Professor Lim, Professor Yang. They did excellent research in this field. So this is something we can work on together later on. Again, main AOP technologies, phantom, ozone, photocatalyst. These are the processes and limitations. If you look at the AOP patterns in South Korea from early 2000 to last year, the number of patterns has increased dramatically in Korea, meaning that this is not only myself, everybody sees AOP is the new trend and where we should thrive on. And among the AOPs, ozone has the largest number in Korea, and photocatalyst and phantom are here. But still, phantom is the traditional AOP, but is still widely used and is well proven, and in the market is well accepted. But the ozone and photocatalysts are kicking in, they are kicking in. And another new trend we should emphasize is the membrane. Actually, we saw Dr. Song and Professor Yang did an excellent presentation on the membrane filtration. Whether it's MF, UF, NF, and RO, all of these are widely used. And commercial membrane filtration system are large-scale systems are also led by the big players, such as the GE from the US, Siemens, Norit from Germany, and Kasei from Japan. But the market size for the precision filtration membrane will be gradually expanding. So there will be some chances other than these major players. So membrane filtration market forecast to 2025 or 28 will be increased. In Korea, in response to the current situation, we are trying to see some different membranes, maybe smaller scale membranes, as Dr. Song showed us, or a specific application of the membranes are researched, and we are trying to develop new technologies in this field. For example, high concentration wastewater treatment, high permeability, and high strength hollow fiber membranes, and low energy, non-polluting precision filtration, next generation separation membrane and modules for the drinking water. These are where we want to do more results and more products from the Korean side. So based on this, what can we do together? I believe three parts. The first part is treatment facilities, conventional treatment facilities. Again, in Korea, we need to design and revamp, and we need to rebuild these facilities. In engineering design and construction, we can share our experiences. As I told you, we have market in Korea. And here in ASEAN, I found Manila and is this Indonesia? Indonesia treatment facilities. They worked with a Spanish company and the Australian company. So we can work together to do a better job for these kind of facilities. This kind of work should be more industry to industry, I think. Maybe NAEK and AAET can do some work to promote this kind of exchange and the co-work. And another part we can work together is a new water industry sectors. As we define the new water industry, these fields, energy, desalination, water reuse, river management, groundwater parts, which I think we can work together. In some parts, I'm sure ASEAN have more experience than Korea. In some parts, we may have more experience than Asia. I think we can do some research. In this field, I think it can be between researchers and researchers or researchers to industry. We can do some collaborations. For energy, water and energy independent wastewater treatment through PID technique with the recovering small water cycle, which is in Anyang, which is near Seoul in Korea. We have some experience like this, and then we can share this kind of information. Desalination is needed all over the world, actually, wherever the water is needed and where the seawater or brackish water is nearby. With abundant coastlines in ASEAN region, there is significant potential for membrane plants to be the major source of the demand. Maybe you are okay now, but later on, when you need more water, membranes can be a very good option. And water reuse, a global water recycle and reuse market will also grow. So these are the key players and the next segments by this kind of the users. So this kind of the water reuse can be, we can do research together, and we can see the field application together. And water management and smart water management system in Korea, K-Water, which was shown by the Dr. Song, has a very good experience in this smart water management system. So we can connect this kind of information between ourselves. Groundwater. Here, groundwater or paddy field being irrigated by tubular tapping underground aquifer. I'm sure it is here in ASEAN region, in Korea as well. We rely on the groundwater for the agricultural water supply. So, but some of the groundwater is not as clean as we want. So sometimes we have to treat them, and we have to do something. Also, we have to secure the groundwater quantity. So in those kind of information and those kind of research can be done together between us. And lastly, new advanced treatment. This is worldwide trend, not only Korea, and I'm sure it's needed in ASEAN, and we can develop some new technology, and we can go for the larger market as well. For example, AOP, membrane, new advanced treatment development. AOP, there are some AOP can be used for the conventional treatment. I myself had experience. We developed a stainless steel plate, and we anodized the surface, and we formed a nanotube. And it's actually effective photocatalyst. And we built them, and we did the pilot test in China and in Korea as well. So I'm sure Professor Lim and Professor Yang, your result can be tested together, and then we want to see further development in this kind of field. And membrane is, of course, we can do some more for the development. So overall, top 10 water treatment trends in 2023, they said more startups are seeing in this field. So these fields are not new. These fields are those fields I just talked about. Actually, this means that we are on the right track. So these can solve our problem as well as some problem somewhere else as well. So hopefully we can talk about this later And then maybe next year, when we further develop this water group between two Asia institutes, I think we need to keep in mind where to work on. Okay. So, but we have to be careful. These water markets are infrastructure, basically infrastructure. It's heavy. It's heavy. Once we have it, it goes 30 or 40 years. So also the demand from public sectors are large and few. It's not like data science. It does not change in a day. So we need more patience. Also demand from the private sectors, which is a little bit less large, less few, but still big, still huge. So we need patience with a long breath, okay? And we need some sort of government incentives and support for the new technology development and application. Since the chances are fewer, new technologies are very hard to get into the market. We need some help from the government. So for that, I think our institutes, AAET and NAEK, can push or can give some advice to governments to be able to see more developments in this area. So ASEAN and South Korea, AAET and Korea is will be further away. We are further north of than you are. By the way, it's very cold here. It's very cold. Here is warm. Korea is, we are talking about negative. Yeah, so very different. But if we look at the numbers, if we sum up the population, we are about 10%, and area is like that. We are quite large. Also, as Dr. Kim, our president, pointed out, you are one of the top traders between Korea and the ASEAN. So I think we want to see more cooperation in these water treatment fields as well. So if one do it only this way, if we can do together, we can reach the goal, right? Yeah. So thank you very much for the presentation. Yeah, let's see.
Thank you, Professor Park, for the showing us the trends and the prospect of the future potential collaboration between ASEAN and Korea. Okay, next, do we have our Dr. Heru Dewanto? Is he back online? If not, then
yes, I believe I am.
Oh, okay, okay.
Oh, welcome, my friend. I can see you.
Okay, next we will have our Dr. Heru Dewanto, the AAET Senior Fellow and immediate past president of the Institute of Engineer Indonesia, PII, and Vice Chairman of Indonesian Chamber of Commerce and Industry. And today, Dr. Heru Dewanto will present his topic on Indonesia Emas 2045, our aspiration to become the 5th largest economy in 2045. I pass the floor to Thank you.
Okay, thank you, everyone. It's good that finally I can meet you all, friends from NAEK, from AAET. So let me just share my presentation. Can you see my presentation?
Yes.
Okay. Well, Indonesia Emas 2045 in English would be Golden Indonesia in 2045. It's going to be 100 years of Indonesia since our independence in 1945. So in 100 years, we aspire to become the 5th largest economy in the world. And I think I don't need to introduce myself again because the moderator just introduced myself. Basically, it's written here, my name and my position. Basically, my background is actually, I'm coming from industry, I'm coming from the business sector. But at the same time, I'm also recently become lecturer at the university. Okay, now this is the report from McKinsey Global Institute, which basically projecting Indonesia to become the 8th largest economy in terms of real DGP, and based on the purchasing power parity, we are going to be the 4th largest economy in the world. And if you can see the where we are today, basically in terms of real GDP, we are 1.12 trillion US dollar, and we aspire to increase it 2.5 times. And in terms of investment, at the moment, 274 billion US dollar, and we aspire to triple it in 2024, 2045. And in terms of labor productivity, which is the GDP per employee, at the moment, we are only 10,000, and we aspire to increase it 3 times. So this is our aspiration. And under this projection, yeah, that's not really our aspiration, but that's the projection from McKinsey Global. And under this projection, which Indonesia become high income country by 2038. So why 2038? Because at the moment we are in the peak of what we call it as the demographic bonus. Yeah. The demographic bonus that we have, the peak period is between 2010 to 2030, basically. And in fact, been categorized as the middle income country since 1993. So we've been trapped for 30 years. Yeah, we've been trapped for 30 years as a middle income country. And our opportunity to escape from this trap is related to what we have at the moment, which is the demographic bonus. So based on the experience of other countries who managed to escape from middle income trap, all those countries basically taking the benefit of the demographic bonus. So speaking about demographic bonus, it will last in 2038. So by that time, we have to be able to take the benefit of the demographic bonus to escape from the trap of middle income. The left-hand side, you can see the categorization of lower income country, middle income country, and high income country, basically determined by GDP per capita threshold. At the moment, our GDP per capita is 4,700 to 5,000 US dollar per capita per year. Now, we need to see our position. What is our strength and what are our challenges? Speaking about Indonesia assets or Indonesia strength, as we all can see that we have a young workforce. We have around 187 million working age population. Basically, we are quite the population can be considered as digitally savvy population. Basically, we have the fourth highest number of internet users globally, which is actually in line with the size of our population. And without a doubt, we have a strong domestic demand because we are the fourth largest population globally with more than 270 million people. And there are many large established players in Indonesia, both domestically and also multinational corporation. Without a doubt, we can also say that we have very rich with natural resources and biodiversity. Speaking about nickel, only we are the largest shareholders, so to speak, because we own the largest deposit of nickel in the world. 22% of nickel deposit resides in Indonesia. And when we are talking about the tropical forests, we have more than 95 million hectares of forests. And when we talk about the potential of renewable energy, we are having like 36,000 actually gigawatt of potential of renewable energy. Hydro energy only, we are talking about 95 potential. Indonesia also very diverse. We have more than 1,300 ethnic groups across the archipelago. We have a lot of creative artists, more than 190,000. And this is considered as our richness, creativity, and diversity. If many countries have one or two signature food, Indonesia has more than 1,000 signature food. Imagine if these foods go global, that could be quite a strong economic presence for Indonesia. And the last is actually our entrepreneurial spirit. More than 97% of Indonesians are employed by as small medium enterprises. However, we have to tackle the key challenges. When it comes to productivity, Indonesia considered as one of the lowest productivity in the region. The average output per hour is only $13, as opposed to Malaysia at $26 and $74 in Singapore. Our skill also, our talent also disproportionately distributed, mostly concentrated in Java. Digital divide still experienced in Indonesia, even though most of the provinces has access to internet, but many provinces basically has less than 40% of penetration of internet. For the last 9 years, basically, we managed to develop infrastructure quite significantly. But when it comes to connectivity, our infrastructure is still lacking in connectivity, which means connecting the production sector with demand sector or market sector. Not to mention connectivity with the global supply chain, global logistic supply chain. Not only connectivity, actually compatibility is a must if we want to become member of the global supply chain. Now, when it comes to the export, basically we are still exporting basic goods and basic resources or raw materials, raw natural resources. Therefore, recently we come up with downstreaming and industrialization of our natural resources, including, among others, are the the minings, and our mineral. Now, disparity in income level also quite serious. In Indonesia, mostly concentrated in urban cities such as Jakarta or Bandung. Even though we have a large number of medium and micro, small, and medium enterprises, but when it comes to the size of the MSME, basically the size is 1/6 of the size of MSME in Thailand. Yeah, so the size or scale of the MSME in Indonesia is very small. So the micro enterprise basically categorized as those who has annual revenue around 300 million per year rupiah. With that, we come up with 4 development theme. The first is boost resiliency. Second, foster prosperity. And third, strengthen inclusivity. And fourth, advance sustainability. Now, this is our aspiration, yeah, for Indonesia Emas 2045. So based on those 4 development theme, resilient growth, basically we aspire to become or included in the top 20 global food security ranking, and also with index score of more than 6 in global biopharma resilience. In prosperous economy, basically we aspire with the 4th largest economy by PPP and 8th largest by GDP in 2045. And we also aspire to escape from middle income country by 2038, as I explained earlier. So vibrant inclusive society is the third theme. Basically, we are talking about equal opportunities for women, Gini coefficient, and the PISA score is our main concern also, particularly, and we would like to be included in the top 20 global PISA score. The score in skill set of graduate, we aspire to have more than 70 score. And then we also aspire to have higher life expectancy for male and female, more than 80 years, child mortality, and also stunting prevalence, less than 10%. So improve infrastructure quality. I think this is very important, not only quality, but also connectivity and compatibility with global infrastructure network. The sustainable development theme, we are on the pathway to net zero emission by 2060, with targets such as 50% of our power generation will come from renewable resources. And we aspire to be top carbon credit issuer. And by 2045, we aspire 50% of our transportation cars, both 4-wheel, 3-wheels, 2-wheels, and also buses will be electrified. Also, 25% of our small holders practice regenerative farming practices. So this is the aspiration of our country, and the spirit supported by the spirit of collaboration and also unity in diversity, or Bhinneka Tunggal Ika. Now, basically, this is the roadmap for each of the strategic growth themes, and we also have key enablers to be developed to support the 4th themes. The boost resiliency, basically, or can I say in other words that, for the last 9 years, basically, we have been managed to develop big size of infrastructure across the country. All aspects of infrastructure has been developed quite significantly. But the issue basically is connectivity and compatibility with the global supply chain network or the global infrastructure network. So once we manage to complete the connectivity and compatibility with the global infrastructure network, then we can imagine we will have a high-speed toll road. So this high-speed toll road, say with speed limit of 300 km per hour, will need a car with stronger engine, more efficient and more effective and more powerful. So we need to build an economy with the engine which is stronger, more efficient, more effective. So which area we have to do this? Basically, we cannot rely on the old economic engine. We cannot rely on the old version of industries. We have to look at new types of industries with higher technology that can offer higher quality of jobs, so that can offer higher wages to our laborers and our employees. So this is the area which we believe can offer higher quality of jobs with higher quality of industries. In these themes of both resiliencies, we are talking about the health resiliencies, including among others, vaccines, pharmaceuticals, and medical devices. This is the area of industries that we aspire to develop in Indonesia in order to provide higher quality jobs with higher wages for our laborers. The same thing happened to food security by breaking through the availability, improving quality, and maintaining affordability. So also in the prosperity, we will enhance strategic manufacturing sectors through Industry 4.0, which means we are not going to invest too much or too many, again, in the existing industries which don't have, which cannot offer higher quality of jobs. So we have to look at new industries with higher quality of job, with higher technology, so that we can offer higher income to our people. Accelerate growth of financial services. This is basically inclusion beyond savings. Then tourism and creative industries become our new engine for our economy. And also, as I explained earlier, the MSME basically cover majority of our business. 97% of our people are employed by MSME. So that MSME has to be having our focus, our attention, and we need to categorization and classification of our big number of MSME and making a micro targeting what to do with each of categorization of each of the classification of those MSME with financing support and other support to the business. And when it comes to inclusivity, basically, we need to improve access and quality of healthcare services. This also offer a higher quality of jobs with higher quality of industries. Now, empowering the vulnerable population. This includes women, disabled people, and having said that, that also offer new industries with higher quality of jobs. And not to mention advanced sustainability, accelerate industrial decarbonization. More than 30% of our basically our emission basically coming from the industries. And the scale green business, yeah, to reach net zero emission, including the 6 key focuses, such as renewable energy, NCS, carbon market, electrification, regenerative in the agriculture, and agroforestry and waste management. Now, for those development theme, we will need key enablers. And we have 5 key enablers. And the first and the foremost is accelerate talent capabilities through education and vocational training programs. Second, basically talking about the global supply chain, the global infrastructure network, how we improve our transportation and logistics across the nation, become more efficient, but more importantly, to be compatible with the global logistic and transportation network. The third, invest in transversal technologies, including digitalization, digital infrastructure, and then developing leaders and unlocking partnerships with our values, which is actually collaboration, and foster diversity of thoughts. Last but not least, regulation. We have to make our legal system, our regulation, we need certainty of law, and all those related to bureaucracy. We have to reduce the red tapes, simplify the bureaucracy by digitalization of our bureaucracy. The permits and all related to the permit need to be simplified and the cost need to be reduced. That's the prerequisite, yeah, for us to enter Indonesia or golden Indonesia in 2045. So basically, this is the area where, like I said earlier, which we expect to offer a better job with higher quality job, with higher wages for our laborers, and that include, among others, the local manufacturing for, prioritized products in the area of health sector. At the moment, we are very much depending on imported medicine, imported medical facilities, medical tools, medical apparatus, and build advanced manufacturing capabilities for new products through partnership with foreign players. So whilst I'm explaining this, basically, this is an opening up for collaboration with any partners, including Korea or any other countries who has anything to offer, to support our aspiration. Basically, we would like to enter into new industries with higher quality of job, with higher technology, which we are not covering before. Food security, for example, we aspire to build inclusive closed loop model, to help scale up the smallholders and maximize domestic production. We aspire to invest in agriculture. It's not aspire, actually, we plan to invest in agriculture innovation to increase productivity. In the prosperity sectors, we like to have a value creation of manufacturing. This include, among others, upstream and downstreaming capabilities in existing sectors. For example, the F&B and textiles, but we also want to develop nascent sectors, including, among others, automotive, chemicals, electronics, and many other new sectors which we haven't entered before. In the financial services, we need to invest in data exchange platform, yeah, to explore establishing of CBDC, wholesale and also retail transaction, and then further develop digital payment solution. And the last one of the most important, increase access for financing for our MSME. Now, in the tourism and also creative economies, we need to boost destination investment and promote sustainable tourism in prioritized location. So we have identified unique location across the archipelago, and we need to pursue investment with partnership with any other partners across the globe, yeah, who can bring added value to our tourism destination, and strategically invest in creative subsectors, yeah, potential innovation, craft, game, music, and film. And then we plan to develop global creative hubs to grow creative products for exports. In the area SME, basically, we are talking about set up and scale national single ID, which is very important to be able to have precise data of our population, and then accelerate existing financial and capability building support. And for micro and small scale enterprises, I think there's one idea to foster one village, one product. If all the villages in Indonesia has one product, then this nation will become very productive nation, because one village come up with one product, whatever the product is. And then for medium scale enterprises, basically we built a lighthouse, mid-sized companies, yeah, in certain prioritized sectors. Inclusivity, talking about the same thing. The spirit of this basically to come up with new idea, entering into new industries, yeah. Healthcare services, yeah. This is all this area, basically offering new business, new technology, and new quality jobs for our population, including also including in the vulnerable population. Same area which we haven't touched quite seriously, will also offer new types of industries, new type of technologies, with basically provide better quality jobs. For example, protect women and disabled population in workplace. You can come up with new, before we haven't really touched this. So we can come up with new technology, new application, or new facilities. Invest in physical infrastructure to ensure accessibility. Yeah, this is also the same thing. So sustainability also the same thing. Sorry, how many more hours? How many more minutes do I have?
See, we already run out of time.
Okay, this is the last thing I believe. Industrial decarbonization and green business bill, yeah, including the accelerate new renewables and NCS, unlocking Indonesian carbon market potential, the CCS, carbon capture and storage clusters, regenerative agriculture, the flagship EV ecosystem, and circular economy and bio-based industries. And this is the key enablers, basically, talent capabilities, logistic infrastructure, and transversal technologies. I think that's I can share with you within this 20 minutes of window of my presentation. Thank you for your participation.
Thank you. Thank you, Dr.
And welcome for any question.
Dewanto. Okay, next we will open for Q&A. Can I have some question from the virtual platform? Is there any question been asked? No question from virtual. Any question from the physical attendance? Or maybe I can start with a question to Dr. Stephen. Regarding the constructed wetland, I think one of the concern normally when we want to commercialize constructed wetland is the high hydraulic retention time, because you need a big area to allow for the absorption of all the nutrient and heavy metal.
Yes.
So what is in your lab? What are the hydraulic retention time you have put into the consideration? And there's another issue is after the absorption of the heavy metal, the disposal of your plants, and you harvest and dispose, that become a hazardous waste. That is another concern. So these are the two questions to you. Thank you.
Yeah, thank you. Yes, thanks for your questions. So answering the first one about the hydraulic retention time. So basically, because in our lab currently we are still running a small scale laboratory based work. So on the phytoremediation, basically we just using the plant to soak into the contaminants waters only. So that's why the hydraulic retention time is not our concern now. But of course, in large scale constructed wetlands, then there's a huge concern. So that's why just now in the slides I will show you different types of configuration of the flows for the constructed wetlands, where you can either go through the subsurface free flow or the vertical flows in using the sub waters. So there are different configuration where you can actually input and provide different hydraulic retention times to your system. So I think that will be able to help in deciding which one to be suitable for your case. Yeah, that's the first one. So for the second question is on the what do you do with the plants after the extractions, right? So of course that's one of our main consideration as well. So that's why after extraction of the plant, for example, in my research currently that I shown you just now, where after the plant that we use to absorb the nickel ions, so currently we are looking at how we can actually extract the nickel ion from the plants itself and then make it into another type of catalyst. So that is how we can reutilize this kind of materials. So far we have quite some successful cases where we managed to extract the nickel ions from the plants and then make it into the nickel-based catalyst. And the efficiency, we use it as one of the photocatalysis as well. So it's proven to be quite effective. So it's one of the reuse of these materials. Yeah, thank you.
Chairman, can just add to your extension to your questions to also the Dr. Stephen's right on this. Just to share with you, actually, under the River of Life project in Kuala Lumpur, where we also have a lot of problems of the industrial waste, especially in many of the flood retention pond, which were formerly also ex-mining pond, and we're trying to actually also improve the water quality in this kind of pond. And I think it's a lenticity of the pond. That's what Dr. Lee mentioned also. But more importantly, is what happened is that we thought probably the right selections of the plants also very important in terms of the availability to resist and also the absorption to all these contaminants. And over 1 year, I want to share with you that through our experience and through our trial, the plants that we selected were killed by the toxicity of the contaminants. And my question is actually basically is that what kind of intensity of toxicity in the effluents that they're talking about? Do you actually take into account the concentrations? And also with that, what kind of plants and the coverage of the plants necessary? Thank you.
Thanks for your questions. So again, for your question, I think I'm afraid I don't have the answers yet, because it really depends on the type of contaminants that you have and also the type of plants that you're using. Yes, and also like for example, the study I've shown you, the plant that I use, for example, for the nickel ion concentrations, for removal of it, you can see, and I increased the concentration level to 5 milligram per liter. So the plant started to not able to absorb anymore, and then it started to die faster. So that's the main optimum concentrations that we are looking at. So if you want to know more about the lifetime or what is the density of the concentration of pollutants they want to treat it, then we need to study more thoroughly on the type of plants and also the effects of it to the plants. Yeah, that will require more thorough studies. Yeah.
Yeah, thank you. Oh, yeah. Can I
Yeah, sure,
Yeah.
sure, yes.
Yeah, I just share with you Korean experience.
Yeah.
Yeah, we are not as warm as you,
Yeah.
so we want to use this plants phytoremediation
Yeah.
for the organic contaminants,
Mm.
but it was not very successful for
Okay.
us.
Yeah.
But we had a very successful case. We had a very huge firing range.
Okay.
It's not just the small guns. We are
Mm.
talking about sort of the big things from the helicopters, and we have used the site since Korean War, 1950s, more than 40 years. And then we need to build a dam downstream of that firing range. So over there, you see many lead because of
Yeah.
those,
The
and also RDX, organic contaminants.
Yes.
Huge area. We couldn't do anything, but
Mm.
we used phytoremediation. So we didn't build the constructed wetland.
Yeah.
It's a slope. We put the plants, and after 1 year, we could collect, we could concentrate
Yeah.
those lead and some RDX.
Mm.
Yeah, so
Yes.
yeah, phytoremediation, if we can do it, is very good,
Yeah,
very
yeah.
ecological, and
Yes, it is. Yes,
one of the way we should go. Yeah.
yeah. And
Yeah.
you can actually retain the pollutants from spreading to other areas. So one way. But of course, the disadvantage is that it takes quite some long time now. So we still need time to improve its efficiency.
Okay, thank you, Dr. Stephen. Next question, please. How about membrane?
Can I ask a question? So,
Yeah, please.
Dr. Song, about your filter membrane preparation product. Is there so regularly you need to change the membrane after use? Do you have to change your membrane regularly, or is there a
Yeah, and I know. Usually we recommend, the drop of the flow rate is 25%. In the case, please cleaning. Usually it takes 6 months. So it means that usually after using 6 months later, please clean by the physical, yeah, by air or something. And some case more than the drop is severe. In the case we guess is more than 1 year later. In the case after physical cleaning, and some case if you want, please using some kinds of chemical treatment can be used. Yeah. It means that generally every 6 months, only by physical cleaning is required. Yeah.
So a commercial question for the household one? What is the approximate price that you're
generally this one. Already I showed this one size is nowadays the amount is the quantity is from, but generally we can say the around below $80. Yeah. 80.
Oh, 80
no.
Okay.
Yeah, 그럼 80. Yeah, that's right. Yeah.
Okay, thank you.
Dr. Song, maybe I can add on that regarding the lifespan of the membrane. Normally, people will put some pre-treatment in front of the membrane to protect the lifespan, to pre-treat.
Yeah.
Before entering, do you have any pre-treatment in front of your membrane, or you don't need?
No need. Yeah. Some case, but in the case the low water is very high turbidity. In the case we need some kind of some mesh. Yeah, in front of our systems. Only we add some kinds of mesh or something. Yeah.
Okay, thank you. Next question.
Yeah. When I was chairing the first session, actually, I caught Dr. Lee's remarks. So I feel very sorry. So you are talking about the role or mission of your institute, right? So can you elaborate a little bit more?
Thank you very much. My presentation consists of two parts. shortly, firstly, the shortly the introduction of the NAEK, our institute, and NIGT, and the second is the main topic, the boiling water. So, however, I have enough time to give a presentation about the boiling water. But the NIGT, I wanted to, I love my NIGT. So I want to give a short introduction about NIGT. NIGT was started from the 10 years ago. Basically, the philosophy of the triangle philosophy. Triangle philosophy. Triangle has a 3 points. One point is technology. One point is fund, and one point is information. And the fund is responsible for the GCF. Do you know the GCF? Green Climate Fund. And the information is responsible for fund. Information is responsible for the GGGI, Global Green Growth Institute. And the technology information is responsible for the NIGT. It's our institute. But at the time, the president is the Lee Myung-bak. The key word is the green growth. However, nowadays, the GCF is changed to the UN organization. And the GGGI is also changed to the UN organization. And so our institute is just only one. But however, a new triangle, the information is CTCN. Do you know the CTCN? Climate Technology Connection and Network. And the fund is the World Bank and the Asia Development Bank and any other bank. And nowadays, we do our best to roll the new triangle, rolling. Yes. Yeah. So anyway, the main function of our NIGT is the agency in the middle of the triangle. Yeah. Thank you.
Thank you, Dr. Lee. I'm afraid that we cannot take more questions. I suggest the Secretariat can share the contact of the speaker, then we can link to each other and ask more questions. I'm sure there are more discussion required, and we are just started. But unfortunately, we have to move on to the next session, which is the souvenir exchange between AAET and our NAEK. So can I invite our Prof. Yu and also Dr. Au on behalf of AAET, and also Professor Park on behalf of NAEK. Okay, next we have the token of appreciation presentation to the moderator, Professor Park. Okay, can I invite our speaker, Dr. Lee first? Next is Dr. Stephen Lim. And we have Dr. Song. Is there another one for Professor Park? Is it? Yeah. That one is for moderator. You have another one for as a speaker. Okay, for the our virtual speaker, I think the secretary will present to you your souvenir after this. And next, can I invite all the participants to have a group photograph together with our president here, Dr. Fogg. Okay, thank you. With that, we will end our forum and we'll move on to the roundtable discussion. Thank you very much for your participation.
Okay, thank you very much to all of you. Yeah, next we will move on to the roundtable meeting between NAEK and AAET. Yeah, you're most welcome to actually continue joining us. Yeah, thank you. Good. So you can sit here. Yes. Dr. Fogg. Dr. Fogg. Yeah. The other side, Dr. Song and probably
International Department.
Professor. Okay, can we connect? So can you show online? Dr. Fogg, link online first. So online Zoom, check online, check online. Yeah, where's Agatha? Yeah. Most welcome to join our next meeting. Roundtable with Korean side. Hello. Show the Zoom screen. Zoom. See that.
I'm the president. Glad to meet you. I'm Lydia.
Yeah. Yesterday you were also here.
I was that busy. I have not attended AAET meeting. I'm sorry.
It's good that you can come this time. Most welcome. That's good. You're from Philippines.
Yes.
Yeah. Just now, yesterday when we were having architect was.
Yeah.
Yes. Yeah. Architect.
Active in AAET.
Yeah. You can join us. I think this Korean side. Where do you want this? Okay. Can we start? Professor Lee? Professor Lee Yin-yu, are you there? From Korea side? Professor Lee Yin-yu.
Yes, I'm here. Hello.
Okay, good. Let's start our discussion. This is the round meeting between the NAEK and AAET. Okay. So it's good. I think here we have about 12 of us here, 13 of us here. Okay. So thank you. And then we have some of our AAT as council members are also attending online. Just now I can see that our AAT council members, some of them also attending online. So let's start our roundtable meeting today. Thank you. Sorry for some delay. I think the forum also just completed. So let's start with the agenda as proposed by the Secretariat. Okay, number 1 is feedback from foreign attendees and identification of potential cooperation areas. Okay, so this is actually, as we know, I think this year we have conducted this is not the first one, but some other forums. And after the survey, and we found out that water and energy, these are the 2 areas we want to focus on and all that lah. So maybe can we open up to any suggestion from maybe your side as well about the forum just now?
Okay, my name is Jeo Park. I was one of the leaders of the working group. We exchanged ideas through the couple of online seminars and hybrid event today, and we came to know each other better. And I think we need some practical, hopefully, results based on our communications. So it'll be good if we can match needs and of the both institutes, and we can find some measurable outcomes out of this. So for that, I think we can still communicate, and then we can exchange ideas and how to proceed based on that. The best idea is sort of the spin-off. Based on the result from this year, we can get some even the small opportunity, or working together opportunity with even start with a small fund. That will be a very desirable, I think. Yeah.
Okay. Thank you. Any others want to actually suggest? Maybe Dr. Stephen Lim. from your side.
Yeah, thanks from you. Yeah, so I actually totally agree with Prof. Park comments. Yeah, basically I think doing a first aid is more to get to know each other's, how do we actually to know our backgrounds, and then how do we work together from there. So I think from the first two seminars that we have done, I think we have more largely know about our backgrounds and what's our research fields and expertise. I think the next phase will mostly to how we can transform this knowledge into more practical things that we can have some physical outputs where we can work together on maybe some research projects or maybe some commercial potential with working together with industry. I think that would be very good. Yeah, that's all my comment. Thank you.
Okay. Any other suggestion, comment?
Can I add on something? Yeah, I am looking at it from the point of view. The point of view is that I think the ASEAN region will benefit more from this collaboration than actually what is in Korea. Yeah. So we have, because our nations, the ASEAN countries are at a different level of development, so they need a lot of such knowledge and expertise to go into the country. So I would like to just suggest to my ASEAN fellows that this is the area that we can actually benefit our respective countries a lot. So we should also participate in this think tank sort of platform that we have now, and ideas which are generated by the think tank can be adopted by their countries, so that we can start on some kind of pilot projects on a small scale to build it up to have more impact on all the brain work that has been done. So I suggest that this will be the more the responsibility of AAET to benefit more from this collaboration that we have on water. So as the Secretary General of AAET, of course, I'm suggesting that I have to be more active to interact with my ASEAN colleagues, so that this in the future, whatever we have been doing, it will eventually be put into actual operation. And where there are opportunities for commercialization, why not? We'd like to make people more, use progressive idea to make the people more prosperous. So I think we take note of that on behalf of AAET. I think we take note of that this is a natural way forward, that we can make use of the effort that is put in by all the clever people that we have. Thank you.
Thank you, Engineer Chu. Okay, no, okay. I think over here, Dr. Yong.
Maybe I just want to have some suggestion. Based on what Engineer Chu has mentioned, respective countries should be able to benefit with this kind of exchanges that we have, in particular with Korea side. Maybe from Malaysia perspective, maybe AAET Malaysia can, example, engage with Dr. Song about their company, and with some Malaysian companies who are already in the water business, and share about what you can provide in terms of the advancement of your product, and where it can be applicable in our country. That is one of the first steps that we can take the initial steps. Then, of course, with you, I'm sure you'll be interested to go beyond Malaysia. So if we can do a starting point with your company support to do this, yeah. And of course, this can be coordinated with AAET. Yeah. Okay, that's my suggestion from you.
Okay, thank you. I think the localized, in this case, meaning that after this, so for example, you're most welcome to also visit the ASEAN countries to meet with the local AAET members, and also the respective companies who are interested in, for example, the technology delivered by the Koreans engineers or companies, so that we can do the matchmaking as well. Okay, then the same goes to all other ASEAN universities, ASEAN countries as well. Okay, so because nowadays we talk about resources, water resources is very important. We talk about any kind of environment, then we need to handle wastewater. And then we talk about energy. I think, of course, energy part is also another part about renewable energy and all that. So I think ASEAN countries, they also are interested to see how we can work with Korean companies and also universities. If it is actually at the university level, then it can be pilot project so that we can have collaboration with various ASEAN universities. If it is about prototype, it's about actually a product already, then we can connect to the companies in ASEAN countries that to bring in the technologies from the Korea companies as well. So I guess this is something that we should move on.
Yes. Yeah, I agree. Yeah, there's more specifics and some opportunities. Some of the opportunities can be introduced by the Dr. Lee, his institute. So some UN fund. So yeah, we can talk this further down the road. By the way, I should have introduced more properly those main person of the NAEK in Korea. Vice President Jung Hee-sung is, no, she's not here yet. Yeah, but we have Professor In-gyu Lee. He is the chair of the international relation of NAEK. So he's ahead of me. So could you say a few words, Professor Lee?
Okay, good afternoon, everyone. I'm sorry I missed the forum, but I'm the chair of the international affair in NAEK, and I hear that the forum went quite well, and I hope that both NAEK and AAET benefit from the insightful discussion on energy, water and energy, and we hope that we can continue this kind of cooperation will result in a quite tangible outcome in the near future. And I have some suggestion from the Song Jung-hee, who is the vice president of NAEK for the next team, but I think I will speak again when we discuss the theme for the next year. Okay, thank you.
Chair, can I have a more specific suggestion?
I cannot hear you.
Can I have a more specific suggestion? Not for you, actually, for all of us.
Okay.
Mr. Chair, am I allowed to speak?
Yeah, of course you can speak.
Can I?
The audio connection from the room is sporadic. I cannot hear you well.
Yeah, I cannot hear the voice, the sound from the forum. Okay, I get a go ahead from the forum. Basically, following to my presentation, which why I emphasized the need for international collaboration in the adoption and acquisition of new technology to support our industrialization strategy or downstreaming strategy. Let me just come up with one specific area, which is in the mineral sector, more specifically in the nickel extraction or nickel processing. Yeah, the nickel ore processing. We would like to, start from the very beginning of the process of the nickel ore. And at the moment, we are very much depending on one technology, which is HPAL technology, high pressure acid leaching. And we believe for the future of Indonesia and also the benefit of Indonesia, that we need to capture not only a certain market, but also another global market. And we believe that we need a new technology which can offer a more sustainable approach. So we would like, or I would like to seek your support or information of any technology, maybe from Korea, that can offer an alternative to the existing HPAL technology, which basically using sulfuric acid to extract nickel from the nickel ore. So I heard that there is one technology in Korea which is being developed for that purpose. So maybe we can develop more specific collaboration, because if anyone from NAEK can come up with a suggestion and relate me with any parties, any companies who has those kind of technology, that could be a real implementation of our collaboration between AET and NAEK. Thank you.
We cannot hear any audio.
But can you hear me? My God.
Professor Lee, let me know if you can hear us.
Yeah, I can hear you now.
Oh, now you can hear us? Okay, good,
Yeah,
good.
yeah.
But can you hear my suggestion?
Oh, yes, we heard, yeah.
Okay, thank you.
Dr. on behalf of NAEK, yeah, we can find the correct person or correct institute who knows nickel ore processing. Yeah, I know your email address and I have your card. Yeah, we will get back to you after we go back to Korea and talk with the NAEK headquarters. Okay?
Thank you.
I give you my promise, okay?
Thank you.
Thank you. I think this is very specific lah. I think definitely it's a good start. So we will actually liaise with the NAEK Secretariat and also Professor Park to look for companies in or this kind of solutions in Korea, and then we will actually channel this one to Dr. Heru. Okay.
Yeah, because if we can, you can realize this collaboration, this will be a breakthrough and a solution to Indonesia. And this can be a good example of our collaboration, a real implementation of a collaboration. Okay.
Thank you. So, okay. So we have actually discussed about this one. Yeah, I've okay. So now it's okay. So next one, I think if we don't have any more comments, we'll move on to the next agenda item. Dr. Fogg, can you project on the screen? This is a review and feedback on ASEAN Korea working group activities. I think this one early this year, after we set up this one, we so far have already 2 webinars. So as Dr. Stephen mentioned just now, get to know each other and all that. So it's good that now we take this opportunity to review back the activities and then see what we need to do further. I think this is very active in the sense that it's on its own. It has conducted 2 webinars to do it. And I think next year, the forum and also the roundtable meeting will be held in Korea to connect further. So maybe we get it. Maybe we check with Professor Lee. Professor Lee, any comment from you from NAEK?
Not. I don't have any specific comment from our side yet.
Okay. How about others? Any comment about this working group? I think it's working well, and we are seeing all this development and all that. And as mentioned by Dr. Heru just now, we need to move on further and really actually implement some of the collaboration projects. So the same thing, I think now getting know each other, then maybe at the university level can do joint collaboration project. And then from the actually enterprises level, we can look for solutions and see how we can implement jointly together, implement this one in ASEAN countries. Okay. So if no, then we can also look at, beside this one, if you look at the next item in the agenda, is actually about, beside this working group and all that, and so far our collaborations and all that, is there any other thing that we need to do for follow-up actions between AAET and NAEK? Because after COVID, now we can have physical visit. Okay. Professor Ao?
Yeah, thank you very much for giving me floor that. Myanmar has a country operation unit of AAET, and we are doing very smoothly. So if you don't mind, from Korea side, we would like to invite the speakers, distinguished speakers from Korea and NAEK side, and via Zoom or something like that. So we would like to conduct the distinguished lecture series in Myanmar. So hosted by my organizations, Myanmar Engineering Council, and also Federation of the Myanmar Engineering Societies. It's my opinion.
Okay. I think that is good. That means that it's a further extension. Now we go to the country level. Okay, and then we have this arrangement. Yeah, Malaysia. Yeah, we can also arrange for that one. Okay. Especially of all this wastewater and other kind of thing. Just now, in fact, I was thinking that Malaysia, we also have company like mineral water, the Spritzer and others. So I'm not too sure that they are interested in just now what Heru mentioned about this removal nickel extraction technology. Then we can also work on that part. Okay. So I think this is good that we are moving on to into the various level and all that. Okay. Besides this working group, currently, Dr. Fogg, this working group is on energy and water, right? So the energy one, how is actually the progress? Energy part? It's separate, right? No, it's one, right? Maybe we think about it. Since the water is I think kicking start and all that, and we can see activity. Maybe next year we want to look at the energy part as well.
So that we can further discuss between NAEK and the AAET. Maybe not today. Professor Lee will get back to you.
Professor Lee, is that okay?
Yeah. We will have a further discussion later through email.
Okay. Yeah, as you all remember, I think early this year and even last year, we have started this survey we conducted this survey, and then it's through the survey result we found that in fact these two areas are the two areas where the ASEAN country and also the Korean companies and all that and institutions, they are more interested. And it is also critical and also in line with these sustainable development goals of United Nations, energy and also water. So it's good that after this, I think next year we will continue to communicate with the NAEK Secretariat and also the International Relations Unit on the next year's activities related to not just water, but also energy. Is that okay? Okay, good. Okay. Now, can I also check with Professor Lee, because I think as what we understand, there's a rotation in terms of the venue that we have this annual NAEK AAET Engineering Forum. So if I understand correctly, next year it will be the turn to go back to Korea, am I right, Professor Lee?
I have to check, but if my memory correct, I think that we agree that NAK and AET takes turn, but the period of the time when the NAK takes a host of this forum is every 5 years, I think.
Yes.
So we have to check when will be the next time that the NAK will host. So after we check those issues within ourselves, then we can also discuss over email.
Okay, good. Okay, thank you. So I think yeah, we can check and then we confirm on this part lah. But okay, in case let's say if this is not the next year to be in Korea and should be in one of the ASEAN country, for information, I think CAFIO will be held in actually Malaysia next year in Sabah. Okay.
Okay.
So there's also another possibility lah. So we'll check no. If it is a turn to go back to Korea, then we confirm with the NAEK. If it is not, then next year, I think it's a good arrangement that we have it in conjunction with CAPIO. So we get to meet a lot of people, and then physically people can meet. That's good turnout as well. Okay, so great. And then of course, that one we can decide later lah, then the exact date and venue next year. Okay.
Okay.
So great. Great for this meeting. Can I check with those online one and also those physically here? Any other suggestion or comment?
I have one more comment. Actually, the Song Jung-hee, who is the VP of our organization NAK, she suggested for the another theme for the next forum. She said, in addition to the water and energy, she thinks that new topic about the digital trade standard would be an interesting one, because there's a lot of global activities going on, how to set up the digital trade standard. I'm not an expert in that area, but she mentioned that digital trade is more broad concept of e-trade. So in the near future, that kind of business will be very critical in global economy. So she suggests that's another one good topic. So we can also discuss about the future topic through email.
Okay. Yeah.
Okay.
I think it's a good suggestion also. In fact, because both NAEK and also AAT, we are also I mean, the background is engineering and then technology. So this digital trade is related. I think the enabler of this digital trade is actually basically all the technical digital infrastructure and infrastructures and all that. So maybe this we can call it digital trade and technology can be the next theme. Okay. Then we can discuss further with NAEK later to confirm.
Okay.
Is that okay? Okay. Okay. Yeah. Agatep, please.
Yeah. we're looking in the Philippines right now. I think the topic for water resources is very good. And we are looking at maybe some sort of a symposium about this thing. Because like if you look on the Philippine map, no, there's about several big islands, and there's small islands that has no water sources. They just rely on rain and deep well, but you know deep well is not good if you are an island country. So I'm thinking of a symposium which we can maybe introduce the water resources. Okay, so maybe within the year, no, but hopefully I can do it during the month of March during the World Engineering Day. Then another one is that when we mentioned about digitalization, no, and we are on the verge of that doing that. Maybe that can be another symposium towards the middle part of the year. Digital trading and maybe you know right now, like if you like get some permits and all these things, no? So those are the application that we're looking at, online renewal, digitalization of the economy, and all this local government. You know, when you apply for a business, need a permit. So right now we do it face to face. So the program of the government is to have it all online, and maybe that can be one cooperation that we can do. In fact, I have some requests for presentation for this thing. But again, no, those are the two topics that I'm really interested, and hopefully we can do it within this, even before we have that round table discussion next year and propose. Okay, so you'll hear from me about these two topics. Thank you very much. But the nearest future will be this coming March during the World Engineering Day.
Yeah, yeah. Okay, good.
Thank you.
Okay. Okay. So I think that's all. And if unless there's any other questions or suggestions, so maybe Professor Lee, do you have anything to add?
No, that's all for now.
Okay. Okay. Then I would just take this opportunity to thank everyone from NAEK and also AAET who participate in today's roundtable meeting. And we are so very happy about so far all the collaboration and progress. And we look forward to more collaborations and more actually projects that we can start next year. Thank you and hope to see you all next year again. Thank you. Okay, bye.
Bye.
Can we take a Zoom photo? Can you all, hope you open your camera. We take a Zoom photo first and then here physically we also take another one and we can merge too. Thank you. Dr. Fogg, yeah, digital. We take the Zoom. Okay. Can you all please open your camera? Take photo, please. Yeah. Okay. Done? Okay. So one more. Okay, that done online. Thank you very much. Then yeah, thank you. Okay, then physically over here, can you all please gather here? So we take another photo. Okay. So those online, thank you very much. Thank you. Yeah. Okay, bye.
Bye.
Thank you, everyone. Goodbye.
Bye.
Bye.
Standing by you, going to forever. After all, it's come and gone.